So good afternoon everyone. So today we will discuss Super 20 questions. This is Super 20 series of machine design subject by keeping GATE 2026 in mind. Okay, so now GATE exam is very near. So we'll discuss most important 20 questions from this subject. Okay, and I try to select those questions now. Through this question, even your entire subject will get revised. Okay, so without any delay, I am starting. Be ready with copy, pen and calculator. Okay, so starting. So see, in machine design, we are going to cover this particular chapters. Like first we'll discuss the question of brakes, then clutches, then design against static load, design against fluctuating load, welded, bolted and riveted joint, bearings, gears and springs. Okay, so these are the chapter whose questions we are going to discuss today. Good afternoon. Na? Okay. So this is first question. Be ready with your copy, pen and calculator. Okay. Start. Okay. See, I am reading the question. To solve the question, I will not give any separate time because at this time, time is very important. Okay. So I don't want to waste your time because time is very important. So I am also starting the reading question, but with me also start solution, and I am hoping that before me your answer and solution should come. See, this is MSQ. What this question is saying, it is very good question. In the short shoe brake shown in figure, the coefficient of friction between shoe and drum is 0.25. Radius of drum is 250 mm. Braking effort P is 9.9 kilonewton. Now, direction of rotation of drum is such that the obtained braking torque in the drum is maximum. This is very important line. Then which one or more of the following option is or are correct? And since it is MSQ, more than one option can be correct. So we have to focus in all the options. Option A is saying drum is rotating clockwise. B is saying drum is rotating anti-clockwise. Means we have to tell what is the correct direction of rotation of drum. In option C, braking torque is 1237.5 Newton meter. D is saying again braking torque, which is 11255 Newton meter. So our second objective is to calculate braking torque. Okay. So see, this is very good question. Na? See, first of all, in the short shoe brake, coefficient of friction between shoe and drum is given. It is 0.25. So mu is given. It is 0.25. And we know for short shoe brake, equivalent coefficient of friction is also equal to mu. That is 0.25. Now the radius of drum is given. So radius of drum I am denoting as R. So it is 250 mm. In meter, it will be 0.25 meter. Now, braking effort P is 9.9 kilonewton. So, braking effort P is given. It is 9.9 kilonewton. In Newton, it will be 9900 Newton. Now, this is very important line. The direction of rotation of drum is such that, very good those. Direction of rotation of drum is such that obtained braking torque in the drum is maximum. So, see, we had to calculate braking torque, but we had to take such rotation in which it is maximum. Okay, we had to take such rotation in which it is maximum. Okay. So see, if for given braking effort, because effort is given, if I want maximum possible braking torque, so in that case, na brake will always be self-energizing brake. In shoe brake, this is very important line. See, what we want for given effort, I want more TB, means more output. Because in shoe brake, the braking effort which we are applying in the lever is our input. The braking torque which we are obtaining in the drum is our output. Okay. And if you want more mechanical advantageous system, what is the meaning of that? More mechanical advantage means for fixed input, output should be more, or for fixed output, input should be less. So right now input is fixed and we want more output. Means we want more mechanical advantageous case. Okay. Or mechanical advantageous case is also known as more effective case. More effective means mechanical advantageous case. Okay. And when shoe brake will be mechanical advantageous or more effective? When it is self-energizing brake. Okay. So if you want more effective condition in shoe brake, it is only possible when it is self-energizing. Okay. So if it is given, if this type of question is coming, that P is given, you have to calculate TB, but take such rotation of drum in which TB is maximum. So for that we want more effective brake. For that self-energizing brake should be self-energizing. Similarly, reverse of that question we can become, might be possible examiner is giving the fixed value of TB and P is unknown, and examiner is saying that we have to take such rotation in which P is as low as possible. So for given output, I want less input, means again it is more effective case. So again brake should be self-energizing. So indirectly question is saying brake should be self-energizing. Then what should be the direction of rotation of drum and what is the maximum possible value of this braking torque? Okay. Now what I am doing, first I am drawing the free body diagram. See, this lever is hinged at this location. This is fulcrum. Suppose I am denoting as O. Now we'll draw the free body diagram of drum and lever separately. So you can see this portion of the drum and shoe are making contact. During analysis, we'll replace this by single contact point, which is the midpoint of this contact region. Suppose I am denoting this point as B. Okay. Now we'll draw the separate FBD of drum and lever. Okay. Now when we'll draw the FBD of lever, we'll see the distance of this point B from fulcrum O. You can see horizontal distance is 315 mm. Now what about vertical means this distance? So this also you can calculate because this distance is 310 mm, you can see, and this is nothing but it is radius of the drum, and radius of the drum is 250 mm. So this distance will be 310 minus 250, that is 60 mm. Okay. Yes. So now I am drawing separate FBD of drum and lever. So actually here 2 point B will come. One point B will belong to drum, FBD of drum. Another point B will belong to FBD of lever. So this is the point B of FBD of lever. This is point B of FBD of drum. For point B FBD of lever, its horizontal distance from fulcrum O is 315 and vertical distance is 60 mm. Now first I am drawing the FBD of drum, but right now FBD rotation of drum is not known. We had to take such a rotation in which brake is self-energizing. Let's check. See, in FBD of drum at point B, always two contact force will come. One is normal force N, second one is friction force mu equivalent N. So to draw normal force N, we'll take such arrow. If you are drawing in the FBD of drum, take such arrow which will try to move point B towards the center of drum. Now if you want to move point B towards the center of drum, we need to go like this. So this is normal force N in the FBD of drum. Now next friction. Friction force will be perpendicular to N. N is vertical, so it will be horizontal. But in horizontal, what will be its sense? That will be decided by rotation of drum. Right now it is not given. Okay. Like if suppose drum is rotating clockwise, so velocity will be this. In FBD of drum, friction will always be opposite to velocity of beam, velocity of point B. So if velocity is this, friction will be this side. If drum is rotating anti-clockwise, velocity of point B will be like this. So friction will be this, like this. But right now I cannot tell whether arrow is this or this because rotation of drum is not given. Okay. So sense is unknown, but it will be along this line, that is 100% sure, and friction force is mu equivalent N. Now whatever contact force is coming at point B in FBD of drum, equal and opposite contact force will come at point B in FBD of lever. So here N is downward. So here at point B in FBD of lever, N will be upward. Friction is along this line. Sense is unknown. So can I say in FBD of lever also friction will be along this line? Only difference, sense will be opposite. Like suppose here friction is like this, so here it will be like this. Here friction is like this, so here it will be like this. Now whether it is like this or like this, but it will be along this line. So this is friction force in FBD of lever. Okay. Now see, this is the FBD of lever. Now we want that brake should be self-energizing brake. Okay, we want our brake should be self-energizing. In short, I am writing self-energizing. Now what is the shortcut trick to ensure self-energizing brake? So see, if we want the brake should be self-energizing, now for that in the FBD of lever, for that see the FBD of lever, the direction of movement of braking effort P about fulcrum and direction of friction force in FBD of lever, this is friction force, about fulcrum must be same if we want self-energizing brake. So right now if you see now, the movement about fulcrum O in FBD of lever due to braking effort P. Right now only see the direction. So due to braking effort P, so P direction is known. So braking effort P is like this, and its direction of movement about O it is rotating like this, which is anti-clockwise. So right now the movement of braking effort P about fulcrum is anti-clockwise. So if we want self-energizing brake, then in FBD of lever, the friction force movement about fulcrum should also be anti-clockwise in FBD of lever. So we'll in this line now we'll take the friction sense such that its movement about O is anti-clockwise. Now we can take two sense, either this or this. Check one by one. Suppose I am checking for arrow A. So for this arrow it is like this. Its movement about O is anti-clockwise, and I want this direction of movement. So can I say here to ensure brake is self-energizing brake, in FBD of lever friction should be towards this side, because as per this arrow its movement about O is anti-clockwise, same as this. Okay, so brake will be self-energizing. Now whatever friction is coming here, equal and opposite friction will come here. So in the FBD of lever if it is like this, and the FBD of drum it will be like this. Now after finding the direction of friction in FBD of drum, we can tell what is the direction of rotation of drum, because we know here friction is opposite to the velocity of point B, So in FBD of drum, if friction is like this, velocity of point B will be like this. And according to this velocity, drum will rotate clockwise direction. So here the direction of rotation of drum is clockwise. So out of option A and B, A is correct, B is incorrect. Now for value, we had drawn the FBD of lever. So now what I am doing? In FBD of lever, I am taking summation of moment about fulcrum O0, because lever will always be in equilibrium. And why I am calculating moment about O? Because at O, his support reaction will come. Suppose it is like this. But the moment of reaction which is coming at O, about O will be 0. So we need not to bother about the reaction which is coming at O, one by one. Moment due to braking effort P about O, and value of P is given, it is 9900 Newton. Okay. Now it is P which is 9900. Its perpendicular distance from O means this distance. This distance is 315 plus 285, 600 mm. So moment of braking effort P about O is 9900 into 600. Direction. So effort P about O, it is rotating anti-clockwise. For anti-clockwise, for clockwise I am using plus. So for anti-clockwise we will use minus. Now in FBD of lever, moment of normal force N about O. So it is N. Its perpendicular distance from O, it is vertical, so horizontal distance 315. Now how it is rotating about O? So it is like this. About O, you can see it is rotating clockwise. For clockwise I am using plus sign. So plus N into 315. Now moment of friction force about O. So friction force is mu equivalent N. That's perpendicular distance from O. It is acting at B horizontally. So its perpendicular distance from O means distance of point B will take vertical distance of point B from O, because it is horizontal, and it is 60 mm. So moment of friction force about O will be mu equivalent N into 60. Now direction. See, it is like this. About O, it is rotating anti-clockwise. For anti-clockwise, we are using minus sign. Moment of reaction at O about O will be 0. That's why I am not writing. This is equal to 0. So in this equation, only one unknown N is coming, that I can calculate. See, N, I am taking common. It will be 315 minus mu equivalent. Mu equivalent is 0.25 into 60. That is equal to, if you shift minus this side, it will become plus. So it is 9900 into 600. So in this equation, only one unknown N is coming. So how much the value of N? It will be 9900 into 600 upon 315 minus 0.25 into 60. Is it coming 19800 Newton? Okay, since we have put it P in Newton, so N will also come in Newton. And after calculating N, we can calculate braking torque, because in shoe brake, always the formula to calculate braking torque is mu equivalent N into radius of drum. Now mu equivalent is 0.25, N is 19800 Newton, radius of drum R, it is 0.25 meter. Why I am putting in meter? Because exam asking braking torque in Newton meter. So if you take N in Newton, put R in meter, TB will come in Newton meter. How much it is coming? Calculation you can check. Is it coming 1237.5 Newton meter? So for this question, the braking torque which is coming in the drum is 1237.5 Newton meter. That is asking in option C and D. So you can see C is correct, D is incorrect. So for this question, the correct options are option A and C. Clear? Very, very, very good. Good going. Yes. Now coming to next question. This is also very good question. Again, it is MSQ. Solve this question. What this question is saying, in the band brake, as shown in figure, the coefficient of friction between band and drum is mu, angle of wrap is theta, drum is rotating clockwise direction. So direction of rotation of drum is given, it is clockwise. Then which one or more of the following option is or are correct? Again, it is MSQ, na? Option A is saying brake is self-energizing. So first we have to check whether brake is self-energizing or not. But along with this, examiner is also asking related to self-locking condition. Like option B is saying it can never go in self-locking condition. C is saying to avoid self-locking condition, e to the power mu theta must be less than 4. D is saying to avoid self-locking condition, e to the power mu theta must be greater than 4. Okay. Here I will suggest don't mug anything, properly solve. By proper method, solve this type of question. Like I am discussing, na? First I am checking whether brake is self-energizing or not. Okay. And direction rotation of drum is clockwise. Okay. Suppose here. Now I am drawing the FBD of lever. Now for that what I am doing? I am cutting the band from both sides. So it will be like this. Okay. So, okay. And at the location from where we have cutted the band, at that location, internal force will come in the form of tension. Now, if you show tension at this location, draw such arrow which will try to elongate this portion of band. For that, we need to draw like this. And whatever is coming here, equal and opposite will come here. Similarly, to show the tension at this location, draw such arrow which will try to elongate this portion of the band. For that, I need to draw like this, and whatever is coming here, equal and opposite will come here. Now, next, this is the FBD of lever, and this is combined FBD of band plus drum. Okay, lever is hinged at this location, which is fulcrum, which I am denoting as O. Now, first we'll identify which side is tight side, which side is slack side. Tight side tension I will represent as T1, slack side tension I will represent as T2. Okay. Now, suppose I am doing analysis for this side, whether it is tight side or slack side. To identify tight side and slack side, we'll always use this FBD. This FBD is combined FBD of band plus drum. Now, what is the method? Suppose I am analyzing for this side tension. So, this side band is attached to the drum at this location. So, we'll draw the direction of linear velocity of drum at this point. Drum is rotating clockwise. For clockwise direction of linear velocity of drum at this point will be like this. Now, if this side tension is in the direction of velocity, this will be slack side. If it is slack side, it is tight side. If this side tension is opposite to the velocity, then it will be tight side. And if it is tight side, it will be slack side. So, right now you can see in this FBD, this side tension is in the direction of velocity. So, this is our slack side. Slack side tension I am representing as T2. And if it is slack side, it will be tight side. Whatever is coming here, equal and opposite here. Whatever is coming here, equal and opposite here. Now, to identify whether it is self-energizing or not, you have two approach. Either you can analyze whether it is self-energizing or not by trick also. What is the trick now? See, in the FBD of lever, see what is the direction of braking effort P about fulcrum. Always see about fulcrum. Now, similarly, see the direction of T1 and T2 movement, direction of movement of T1 and T2 about fulcrum also. Okay. Now, whatever direction of braking effort P, direction of movement we are getting for braking effort P about O. If same direction of movement of about O we are getting either due to T1 or due to T2, then it will be self-energizing brake. Okay. And whatever direction of braking effort P we are getting about O na, if same direction of movement about O is coming due to T1, that will be self-energizing due to tight side tension. If same direction of movement is coming about due to T2, that will be self-energizing due to slack side tension. By this trick also you can check. Right now, in the FBD of lever, braking effort, movement of braking effort P about O is clockwise, you can check. Now, movement of T1, FBD of lever, this is T1, about O is also clockwise, but movement of T2 about O is anti-clockwise. So, the direction of movement of braking effort P about O is clockwise, same direction of movement about O we are getting due to T1. So, it is self-energizing due to tight side tension. Now, due to whatever reason, but it is self-energizing or not, it is self-energizing. So, A is correct. But that you can identify by deriving the equation also. Okay, how? See, in the FBD of lever, for self-locking, even you need to find this equation. Okay, so you need know, even without using this trick, you can conclude it is self-energizing. How? In the FBD of lever, I am taking summation of moment about fulcrum O and equating with 0 one by one. While writing this moment equation, suppose for clockwise I am using plus, for anti-clockwise I am using minus. Now, moment of braking effort P about O, it will be P, its perpendicular distance from O, means this say it is not given, so let's say it is L. So, it is P into L, direction, this effort P is rotating about O clockwise, for clockwise I am using plus sign. Now, in FBD lever, moment of T1 about O, T1, its perpendicular distance from O, it is vertical, so horizontal distance 50, about O it is rotating clockwise, for which I am using plus sign. Now, moment of T2 about O, T2, its perpendicular distance from O, you can check it is 200. How it is rotating about O? It is like this. About O, it is anti-clockwise. For clockwise, I am using plus, so for anti-clockwise, minus. Now, moment of reaction at O about O will be 0. So, we need not to bother about the reaction which is coming at O. Equate with 0. From this, you can find the expression of P, it will come. This plus will go this side, it will become minus. Minus will go this side, it will become plus. So, ultimately, it will be T2 into 200 minus T1 into 50. Divided by L. So, see, this T1 50 part is reducing P, means again it is self-energizing brake due to tight side tension T1. But whatever is the reason, it is self-energizing, so E is correct. Now, for self-locking now, simply I am discussing this question, but it might be possible if this question is coming due to for anti-clockwise rotation of drum. In that case, now it will be self-energizing due to slack side tension. So, first understand this conclusion which I am going to tell right now. See, whenever brake is self-energizing due to tight side tension, like here it is self-energizing due to tight side tension. Here na brake can be in self-locking also, it cannot be in self-locking also. For that, what we'll do now, in this type of question, we'll always find the condition to avoid self-blocking. To avoid self-blocking, what condition I need to satisfy? P must be greater than 0. So we will find the condition to avoid self-blocking, that is P must be greater than 0. That condition we will find. And if that condition is not satisfying, it will be in self-blocking. If that is satisfying, means self-blocking will not occur. Okay. But if brake is self-energizing due to slack side tension, then you can rightly remember brake can never be in self-locking condition. Means you need not to satisfy any condition. It can never be in self-locking. Okay. But right now it is self-energizing due to tight side tension. So we need to find the condition to avoid self-locking. Okay. Okay. And what is the condition to avoid self-locking condition? The braking effort P must be greater than 0. Yes. Now when it will be greater than 0, when this above part is greater than 0, above part means T2 into 200 minus T1 into 50 must be greater than 0. From this T2 into 200, can I say it must be greater than T1 into 50? Do calculation carefully na. If you shift 50 below side, 200 by 50 is 4, must be greater than T1 by T2. So you can see in the side of T1 by T2 less than sign is coming. So can I say T1 by T2 must be less than 4, and T1 by T2 is nothing but e to the power mu theta. So e to the power mu theta must be less than 4. Okay. So here can I say to avoid self-locking, e to the power mu theta must be less than 4. Okay. So to avoid self-locking, e to the power mu theta must be less than 4. So C is correct. Now you cannot say brake can never be in self-locking condition, because here both conditions are possible. Na? To avoid self-locking, I need to satisfy e to the power mu theta less than 4. So for this question, correct options are A and C. Okay. Yes. But suppose now same question is coming for anti-clockwise rotation. Again brake will be self-energizing, means A will be correct. But in that case now brake will be self-energizing due to slack side tension. That you need not to remember. Again if you do derivation, automatically that conclusion will come. And if it is self-energizing due to slack side tension, then it can never be in self-blocking condition. So for that question, B will be correct. But right now for this question, A and C are correct. Okay, very good. Now moving ahead, solve this question. Now we are discussing the question of clutch. This is the question related to multi-plate clutch. Okay. What this question is saying, a multi-plate or multiple disc clutch is to operate, this is multiple choice question, means out of this 4 options, 1 option will be correct, is to operate in oil and able to transmit a design overload torque of 1500 Newton meter. M is the number of disc or plate on driving shaft. N is the number of plates on driven shaft. Inside and outside diameter of the plate are 120 and 240 mm respectively. Coefficient of friction between contacting surface is 0.25. Permissible pressure is 0.8 megapascal. So as per uniform wear theory, which one of the following option is correct? And examiner asking the value of M and N. What is M? M is number of plates on driving shaft. What is N? N is number of plates on driven shaft. Okay. Yes. Okay. So see, a multi-plate disc clutch has to torque is 1500 Newton meter. In Newton mm, it is 1500 into 1000 Newton mm. This torque we have to transmit. Okay. M is number of plates on driving shaft. Okay. N is number of plates on driven shaft. That I am not writing. But see, if number of plates on driving shaft and driven shaft is given, then formula to calculate number of pair of contacting surface. Here I am denoting number of pair of contacting surface as capital N. Because small n I am taking notation for number of plates on driven shaft. So see, the formula to calculate number of pair of contacting surface is M plus N minus 1. This we are discussing in the class. In class we were denoting number of plate and driving shaft as N1. It was our notation. Number of plate on driven shaft as N2. So number of pair was of contacting surface was N1 plus N2 minus 1. So here it will be M plus N minus 1. Okay. Now here one interesting result you can use. We had discussed in the class, number of plate on driving shaft will always be 1 more than N2. So N1, that is M, is nothing but N2 plus 1, or N2 is N. So N plus 1. Okay. Means M will always be equal to N plus 1. Like if you use this conclusion, you can easily eliminate option B and C. Because number of plates on driving shaft is 1 more than number of plate on driven shaft. So B and C is eliminated, because here it is more. Actually it will be more. Okay, here both are same, so it is also incorrect. Now either A will be correct or D will be correct. As per option A, can I say number of pair of quantitating surface are 4, 3 plus 2, 5 minus 1. As per option D, the number of pair of quantitating surface are 4 plus 3, 6, 7 minus 1, 6. So either A will be correct, D will be correct. For that I need to find the capital N. Okay. Now after that, what data is given? The inside and outside diameter of the plate are 120 and 240 mm respectively. So inside diameter is 120 mm. So inside radius, can I say it will be half of 120, that is 60 mm. Outside radius is 240 mm. So, sorry, outside diameter is 250 mm. So outside radius will be half of 240, that is 120 mm. Yes. Coefficient of friction is 0.25. So mu is 0.25. Permissible pressure is 0.28 megapascal. So it is permissible pressure, na? Means actual maximum pressure should be less than equal to this. To find limiting value, we can equate maximum pressure with permissible. Then exam asking as per uniform wear theory, which statement are correct. So we have to find this as per uniform wear theory. Okay. Now we know as per uniform wear theory, the formula to calculate torque transmitted by the clutch is N is number of pair of quantitating surface into mu into W into RM. RM mean radius. For uniform wear theory, mean radius is R0 plus Ri divided by 2. Okay. But what is the formula to calculate W here? So see, what is W? W is axial force at engaged position. For uniform wear theory, formula to calculate this is 2 pi C in bracket R0 minus Ri. What is C? In uniform wear theory, we assume the product of pressure into R is constant. That constant we represent as C. Now, if maximum pressure is given, then formula to calculate C is, see here with increase in R, pressure will decrease. So, can I say in uniform wear theory, pressure will always be max at minimum value of R, that is at R equal to Ri. So, here if I will replace P by P max, R will be Ri. So, you can say replace 2 pi C is P max Ri into R naught Ri. So either first calculate W here and put here, or if you want, you can directly put the expression of W here. It is your will. Suppose I am putting the expression of W, so it will be N into mu into W. W is 2 pi C, C is P max Ri into R naught minus Ri into R naught plus Ri divided by 2. Okay. Now torque is given, it is 1500,000 Newton mm, and into mu. Mu is number of mu is coefficient of friction, which is 0.25 into 2 into pi into P max. P max is maximum pressure, which is 0.8 megapascal. Ri inner radius, it is 60 mm. Okay. Okay. Into. Now, can I write this 1 by 2 first I am writing? Now, it is nothing but A minus B into A plus B, and A minus B into A plus B will be A square minus B square. So, if you want, you can also write like this. R naught square, and R naught is 120, so 120 square minus Ri square. Ri is 60, so 60 square. It is your will how you want to proceed. So, how much number of pair of quantitating surface is coming? 1500,000 into 2, answer divided by 0.25 into 2. Check the calculation. Na? Is it coming 3.684? Okay. Okay. Yes. Now see, number of pair of contact surface cannot be in point. Na? It will always be a natural number. So what we'll do? So whatever limiting value is coming, na, actual N will take greater than this. Okay. Because see, if it will take less than this, suppose you are taking 3. So torque transmitting capacity will be less than 1500, but I want the torque transmitting, this is the minimum requirement. So that's why whatever number of pair contact surface I will take, now I will take more than this. So first next greater value for then this is 4. So first I will take N is equal to 4. Okay. Now see, now N equal to 4 is possible or not as per option. So as per option A, N is equal to 4. So A is correct, D is incorrect. Yes. So for this question, now don't say sir, B is also possible, 2 plus 3, 5 minus 1. No, it's not correct, because first of all, M will always be 1 greater than N. Na? So that's why already I eliminated B and C. Now either A will be correct, D will be correct. So for this question, which option is correct? D, because number of pair of contacting surface should be, sorry, option A, because number of pair of contacting surface should be 4. Very good, those. Good going. So for this question, option A is correct. Okay. Now moving ahead, This is also very good question. This is numerical answer type question. Try this question. Here na equation of pressure distribution is given. So here you need not to use any theory. We'll solve the problem by integration. See what this question is saying. This is very good question. The inner and outer diameter of the friction disc are 150 and 250 mm respectively. Coefficient of friction between contacting surface is 0.25. The pressure intensity on the disc is given by equation P is equal to Kr to the power minus 2, where P is pressure at radial distance R from axis of shaft and K is constant. So this equation is given. Axial force at engaged position is 10 kilonewton. So it is given. Then what is the value of torque transmitted by the clutch? This is very good question. See, first of all, what question is saying? Inner and outer diameter of the friction disc are 150 and 250 mm respectively. So inner diameter is 150. So inner radius will be half of 150, that is 75 mm. Outer diameter is 250. So outer radius will be half of 250, that is 125 mm. Yes. Now coefficient of friction mu is 0.25. Equation of pressure as a function of R is given. P is equal to Kr to the power minus 2. So can I say it is P is equal to K upon R square, where P is pressure at a radial distance R from axis of shaft and K is constant. Suppose this is equation 1. Now axial force at engaged position is given, that is W. It is 10 kilonewton. In Newton it will be 10,000 Newton. Then examiner asking what is the torque transmitted by the clutch. Okay. Now whenever it is not mentioned, it is single plate clutch or multi plate clutch, we will always assume single plate clutch and will take number of pair of contacting surface equal to 1, because in single plate clutch also two cases comes, one side effective or both side effective. For one side effective, number of pair of contacting surface will be 1, for both side effective it will be 2, but if it is not mentioned in the question, we will always assume it is single plate clutch with one side effective, and for that case number of pair of contacting surface will be 1. Okay. Yes. Now, see here now, since equation of pressure as a function of R is given, so we will not use any theory. Simply by integration we will find the expression of torque. But by integration we find the expression of torque. In that expression constant K will come, because right now K is constant but its value is not known. So examiner will give such information through which we can calculate the value of K. Like here the value of W is given. So we can derive the expression of W also by integration. Again it will come in terms of K. And since W is given, so from that we can calculate K. So by using the value of W, first I am calculating K, because what is the formula to calculate axial force at engaged position by integration? Solve by integration. It is nothing but integration P into 2 pi R dr. How you can remember this? Just as imagine pressure at a radial distance R is P into strip area, and clutch strip area will be 2 pi R dr, and integrate from Ri to R naught. Now I am taking force in Newton, dimension in mm. So W is 10,000 Newton, integration Ri to R naught, Ri 75, R naught 125. If pressure equation is K upon R square into 2 pi R dr. Calculation is your part. 10,000 is equal to K. K is constant, so we can bring outside integration. 2 pi is also constant. So here R upon R square means 1 by R will remain. So 1 by R into dr, that is dr by R. And integration of dr by R is log R. It is log of base E. In your scientific calculator, ln is log of base E. Limit is 75 to 125. How much it will come? 10,000 is equal to K into 2 pi in bracket. For upper limit, it is log 125 minus lower limit log 75. So now we can see in this equation only one unknown K is coming. So we can find the value of this constant K. How much it is coming? 10,000 divided by 2 divided by pi divided by this term. Is K is coming 3115. Check my calculation. 0.641. This is the value of K or not? 3115.641. Now after finding the value of K, put in equation 1. P is K upon R square. K is 3115.641 upon R square. Suppose this is equation 2. This is final equation of pressure. Now you can calculate pressure of any point by using this equation. Okay. But just remember, here we'll put R in mm. And we'll get P in megapascal or Newton per mm square, because during finding K we have used this unit. Now for force we have used unit, for force we have used Newton, for dimension we have used mm. So here also if you are putting R, put R in mm, you will get pressure in Newton per mm square. But right now our objective is to calculate torque transmitted by the clutch. So now I can find the expression of torque by integration. What is the expression torque? It is by integration. The formula to calculate torque transmitted by clutch is, first of all, take n, which is number of pair of contacting surface, into now torque transmitted by one pair of contacting surface. And formula to calculate torque transmitted by one pair of contacting surface is integration Ri to R naught mu P 2 pi R square dr. How you can remember this? See, pressure force on strip is P into 2 pi R dr into mu, it will be friction force, again multiply with R. So 2 pi R dr into R, it will become R square. So you will get the torque transmitted by strip, integrate, that will be torque transmitted by one pair of contacting surface into n, that will be total torque transmitted. But right now n is 1 na? Into integration Ra to R naught, Ra is 75, R naught 125, mu 0.25. The equation of pressure, now this is the final equation, 3115.641 upon R square into 2 pi R square dr. Now solving is your part. Okay, see this R square will get cancelled, so it is very easy. 0.25 is constant, it will come outside integration. 3115.641 will also come outside integration. 2 pi will also come outside integration. So inside it will be only dr. Now integration of dr is R. In R if you put upper limit, it is 125, minus lower limit, it is 75. Okay, so how much it is coming, calculation is your part na? Is it coming 244,701.872 Newton mm, because we have taken force in Newton, dimension in mm. Now examiner is asking in Newton meter. So to convert mm into meter, we will multiply with 10 to the minus 3. So it will be 244.702 Newton meter. So for this question, torque transmitted in Newton meter is coming 244.702. Okay, you round out this up to 2 decimal place, it will be 244.70. Very, very good. So this is good going. Vibhu Varok Depalli. So for this question, correct answer is 244.7. Once you are solving any question, na, just increase your confidence. Okay, appreciate yourself. It will increase. Okay, yes. Now this question, this is multiple choice question. It is the question of centrifugal clutch. What this question is saying, a centrifugal clutch is transmitting 600 Newton meter torque, consists of 4 shoes. The inner diameter of the drum is 400 mm. The radial distance of center of gravity of each shoe from axis of shaft is 100 mm. Spring force at engaged position is 1000 Newton and running speed is 100 radian per second. Okay, what is coefficient of friction is 0.3. Then examiner asking mass of shoe. Mass of shoe. Definitely whatever running speed is given, that is engaged position. Because torque transmitted by clutch is given, so and torque will only transmit at engaged position, so it is engaged position. Now what is the mass of issue? First I am writing given data. Okay, see here the torque transmitted by the clutch is 600 Newton meter. In centrifugal clutch na, I generally use SI unit, which will take force in Newton, distance in meter. Number of shoes that I am denoting as Z, it is 4. The inner diameter of the drum is 400 mm. So inner radius, here we require radius. Inner radius of the drum will be 200 mm. Half of 400 in meter, it will be 0.2 meter. The radius of center of gravity of each shoe from axis of shaft is 100 mm. Radius of center of gravity I denote as RG. So it is 100 mm. In meter, it will be 0.1 meter. Now spring force at engaged position is 1000 Newton. See, in centrifugal clutch now we have discussed in the class also, and I think before yesterday in Maha revision also I discussed that spring force in centrifugal clutch, spring force of all engaged position will be constant. Okay, reason, because once clutch is getting engaged, after that further elongation of spring cannot occur. So that's why spring force of all engaged position will be constant. Okay, and the value of that is given, it is 1000 Newton. Now running speed means it is actual speed, which is 100 radian per second. Omega, coefficient of friction is mu, which is 0.3. Then examiner asking what is mass of issue, suppose that I am denoting as m. Just for understanding, na, at engaged position, if you draw the ABD of one shoe in a centrifugal clutch, it will be like this. But you can directly remember the formula. And this is engaged position. Now at engaged position, suppose this is the center of gravity of shoe. Here in outward direction, one centrifugal force will come. The formula to calculate this way is always mRg omega square. Okay, this is centrifugal force. In inward direction, because at engaged position spring is elongated, so here one spring force will come in inward direction like this. Okay, value of spring force is given, it is 1000 Newton. And actually if it is engaged position, so it is 100% sure for engaged position Fc will come more than Fs. Automatically it will come more than Fs if it is engaged. Then what is the formula to calculate torque transmitted? Now, this you can do, analysis you can do in your mind also. So see how I can write. So at engaged position, centrifugal force is Fc, spring force is Fs. I am 100% sure if it is engaged, Fc will be more than Fs. This relation is only valid for engaged position. So here net normal force will come, which is Fc minus Fs. Multiply with mu, it is friction force at one shoe. Multiply with Rd, because this friction force will come at this contact point. Okay, whether it is like this or like this, whose radial perpendicular distance from axis of shaft is equal to Rd, which is inner radius of drum. So multiply with Rd, it is torque transmitted by one shoe, into Z, it is total torque transmitted. So we'll use this equation. Okay, torque is given, yes, Z is given. We have to calculate mass of this shoe. For that first I will find Fc, because Fc is mRg omega square. So if we found Fc, we can find m also. Okay, so I'm doing calculation now. So what I'm doing, torque is given, it is 600 Newton meter, Z is 4, mu is 0.3 into Fc minus Fs is given 1000 into Rd, which is inner radius of drum, it is 0.2 meter. So from that we can calculate Fc, because torque is transmitted means definitely it is engaged position, and for engaged position this relation is valid. How much it is coming? 600 divided by 4 divided by 0.3 divided by 0.2. So see, Fc minus 1000 is coming 2500 Newton. So Fc will be, minus will come this side, will become plus. So 2500 plus 1000, that is 3500 Newton. Now Fc is mRg omega square, which is 3500. M is mass of issue, which we want to calculate. Rg is radius of center of gravity of shoe, which is 0.1 meter. Omega is actual running speed, 100, so 100 square, that is equal to 3500. So from this we can calculate M, which is mass of issue. Now how much it is coming? 3.5 kg. You can check the calculation. Clear? So for this question, the required mass of issue is 3.5 kg. Very good. Appreciate yourself. Matching with which option? Option B. So for this question, B is correct. Okay. Now moving ahead. Now I am discussing the question related to design against static load. So now moving to next chapter, which is design against static load. Solve this question. This is multiple select question, means again more than one option can be correct. So you have to focus in all the option. A shaft of diameter 160 mm is subjected to combined bending and torsion moment of 60 and 80 kilonewton meter respectively. Good. Tensile yield strength of the shaft material is given, which is 210 megapascal. Then which one or more of the following option is your correct? In option A, examiner saying as per Rankine theory of failure, shaft yields, means yielding of that yielding is starting, but as per Rankine's theory. B saying it will not yield. Okay. C saying as per Tresca's theory of failure, shaft does not yield. D saying as per Tresca's it will yield. So we have to check first as per Rankine. In Rankine, criteria of failure is maximum normal stress, and second we have to check as per Tresca. In Tresca, the criteria of failure is maximum shear stress. Okay, see, it is a case of combined bending and torsion. So suppose this is the shaft. The diameter of this shaft I am denoting as D. It is 160 mm. Okay. Now it is subjected to combined bending moment. Suppose bending moment is same throughout, that I am denoting as M. It is 60 kilonewton meter. Torsion moment is also same, T, which is 80 kilonewton meter. The tensile strength, yield strength of the material is given. Suppose that I am denoting as SYT. It is 210 megapascal, and we have to check as per Rankine and Tresca. But here examiner asking, it is not the question of design. The question is saying design is given. Now the design is safe or not, or it is yielding or not yielding as per Rankine theory, and second as per Tresca's theory. Okay. So see, if you are first, suppose we are checking as per Rankine's theory. So see, in Rankine's theory, what is the criteria of failure? Maximum normal stress. So as per this theory, when our specimen will be safe, as per Rankine's theory, when our specimen theory, when our specimen will be safe, when safe, if it is safe means it is not yielding, because if yielding is occurring means it is getting failed. When actual maximum normal stress and at critical point under actual stress condition is less than the maximum normal stress under tensile test at the time of failure, and under tensile test at the time of failure, maximum normal stress will be equal to tensile strength, which is SYT. So if it is less than SYT, it will be safe, and the value of SYT is 210 megapascal. So see, if sigma max is coming less than 210 megapascal, it is safe, means it will not yield. Means can I say it will be unsafe? Unsafe means yielding will start when sigma max is not satisfying this, means it is greater than 210. So what we will do, as per Encke's theory, if you want to check, find the expression of sigma max and see whether it is less than 210 or more than 210. So just calculate. Now here we know direct formula to calculate sigma max, because in combined bending and torsion, okay, if the suppose bending moment of the critical cross section is m, here if you calculate the magnitude at critical cross section, here you can take any cross section as critical, because bending moment and torsion moment is same throughout. So suppose I am taking this, so bending moment of this critical cross section is also m, which is 60 kilonewton meter. In Newton mm, it will be 60 into 10⁶ Newton mm. Similarly, torsion moment is also same throughout. So for critical cross section also torsion, same value of torsion moment will come, which is Z, it is 80 kilonewton meter. In Newton mm, it is 80 into 10⁶ Newton mm. Now in combined bending and torsion, if you know the bending moment and torsion moment at critical cross section, diameter of the shaft is D. So for this case, we directly remember the formula to calculate tau max and sigma max. How? The formula to calculate sigma max in combined bending and torsion is 16 upon pi d cube m plus root over m square plus t square. And this will also denote as principal stress sigma 1. Similarly, if you write the expression of sigma 2, here it is not required, but if you want, here instead of plus, minus will come. And sigma 3 will be 0, because under combined bending and torsion, it will be plane stress condition. So sigma 3 will be 0, but that I am not writing because we want sigma max. Similarly, what is the expression of tau max? If the bending moment at critical cross section is m, torsion is t, then formula to calculate tau max is 16 upon pi d cube root over m square plus t square. This you can directly remember for combined bending and torsion. Derivation of this we had done in the class. And here we will put the magnitude of m and t. Okay. So here I want sigma max. So sigma max is 16 upon pi d cube m plus root over m square plus t square. Yes. So 16 upon pi d cube. Diameter is 160. So 160 cube in bracket. Now when we will put m and t, in m and t this 10 to the power 6 part is common. So here 10 to the 6 will come. Here 10 to the 6 square, 10 to the 6 square will come. You can take common. It will come outside root. Again 10 to the power 6 will come outside root. So from this entire equation, I can take 10 to the power 6 outside. Okay. So now here put the value apart from 10 to the 6. So apart from 10 to the 6, in m 60 is coming and in t 80 is coming. So it will be 60 plus root over 60 square plus 80 square. Calculation is your part. So how much sigma max is coming for this case? It is 60 plus root over 60 square plus 80 square into 16 into 10 to the 6 divided by pi divided by 160 cube. Is it coming? 198.944 megapascal. Very good. Now it is satisfying this or not? Yes, it is less than 210. Means can I say as per Rankine theory it is safe? Safe means it will not yield. But it is as per Rankine. So as per Rankine it is not yielding. So option B is correct, A is incorrect. Now next we have to check as per Tresca also. So now what is the conclusion as per Tresca's theory? So in Tresca's theory, criteria of failure is maximum shear stress. So here when our shaft will be safe, safe means does not yield. So whatever condition is coming, it is satisfying. It will not yield as per Tresca. If it is not satisfying, it will yield. So see here criteria of failure is maximum shear stress. So under, can I say maximum shear stress under actual stress condition? It must be less than the maximum shear stress under tensile test at the time of failure. Now if tensile strength is SYT, maximum shear stress under tensile test will be 0.5 SYT. For tensile test, this is the conclusion. If max tensile strength is SYT, maximum shear stress under tensile test will always be 0.5 SYT. So if it is less than this, it will be safe. Now value of SYT is 210 megapascal. Yes. So can I say if tau max is coming less than 0.5 into 210, that is 105 megapascal. It will be safe, means it will not yield. And if it is greater than 105, it is not safe, means yielding will start. So let's check. Now what is the formula to calculate tau max here? It is 16 upon pi d cube root over m square plus t square. Now 16 upon pi, diameter is 160, so 160 cube. Now m is 16, 10 to the 6, 10 to the 6 is common part I am writing outside. So inside root we'll put the value apart from 10 to the 6. So in m apart from 10 to the 6, 60 is coming, so 60 square. In t 80 is coming, so 80 square. So how much it is coming? 60 square plus 80 square into 16 into the 6 divided by pi divided by 160 cube. Is it coming 124.34 megapascal and it is greater than 105? Means this condition is not satisfying. Means as per Tresca's theory, it is not safe. Not safe means here yielding will start. Yielding starts. So as per Rankine, yielding is not starting, but as per Tresca, it is starting. So as per Tresca, shaft will yield. So D is correct, C is not correct. So for this question, the correct options are option B and D. Very good Virok, very good Anubhav. So these are the correct options. Okay. Now moving to next question. Solve this question. This is numerical answer type question. What this question is saying, a thin cylindrical pressure vessel of diameter 1 meter is subjected to internal pressure of 2 megapascal. It is given. Along with this, it is also subjected to axial compressive force, which is 505 kilonewton. Thickness of the cylinder is 10 mm. Tensile strength of cylinder material is 380 megapascal. Then what is the factor of safety as per Tresca's theory? Okay, so we have to calculate factor of safety as per Tresca's. This is very good question. See, it is the diameter of this cylinder is 1 meter. So in mm, it will be 1000 mm. It is subjected to this internal pressure P, which is 2 megapascal. Along with this axial compressive force is also coming. Suppose that I am denoting as F. It is 500 pi kilonewton. In Newton, it will be 500 000 pi Newton. Now, thickness of the cylinder is 10 mm. Tensile strength is given. So, tensile strength I am denoting as SYT. It is 380 megapascal. Then we have to calculate factor of safety as per Tresca's. Tresca's means shear stress theory. In shear stress, criteria of failure is overall maximum shear stress. So, we will find maximum shear stress at critical point. Okay. Yes. Now, in thin cylinder, first calculate all the principal stresses at critical point. Okay. And this is the question of strength of material first of all. Finding factor of safety is the question of machine design, but finding stress at critical point is the question of strength of material. Now, whenever see in thin cylinder, if it is subjected to internal pressure also or axial force also. So here mainly three type of stress induces, which is circumferential stress, longitudinal stress, and next is radial stress. Radial stress I will write later. Suppose this is circumferential, this is longitudinal. Okay. Now see circumferential stress always comes only due to pressure. It has nothing to do with axial force. And due to net internal pressure, formula to calculate circumferential stress is always plus PD by 2T. Why I am saying plus? Because for tensile I am using plus, for compressive I am using minus. So due to internal pressure, circumferential stress will always be tensile. Now pressure is 2 megapascal, D is 1000 mm, twice of thickness. Thickness is 10 mm. So how much circumferential stress is coming? 2 into 1000 divided by 2 divided by 10. It is coming 100 megapascal. Okay. Now what about longitudinal stress? So see, actually longitudinal stress will come due to two reasons. One, due to pressure. Due to internal pressure, formula to calculate longitudinal stress is always plus PD by 40. Means actually it is half of this. But it is due to pressure. But here along with pressure, axial force is also coming. So here due to axial force also longitudinal stress will come. Because what is longitudinal stress now? Longitudinal stress, the stress which is coming in this cross section of the cylinder. Because in this cross section means in this plane. In this plane, if you draw normal stress now, it will be perpendicular to this plane. And the direction which is perpendicular to this plane, whether you are drawing like this or drawing like this, is along length, means it is coming in longitudinal direction. Okay. So actually, the normal stress which will come in this section is nothing but it is longitudinal stress. Now formula to calculate longitudinal stress due to pressure is PD by 40, which you have written. Now what about axial force? Now forget pressure, only consider the axial force. So first of all, what is the axial force in this section? If you are ignoring the pressure, take right portion of this section, only one load F is coming. This F is perpendicular inward with respect to this section, means it is compressive. Now for compressive, I am using minus sign, because for tensile I am using plus sign. So it will be minus. And due to axial force, formula to calculate sigma L is axial force F divided by pi dt. If you want, you can remember this, because axial force is F divided by area of this plate. And this is hollow circular section, but it is thin. And for thin hollow circular section, formula to calculate area is pi dt. You can remember this as formula. If axial force is tensile, here plus will come. It is compressive, here minus will come. So since it is compressive, that's why I'm using minus. Now P is 2 megapascal, D is 1000, 4 thickness is 10 mm, minus axial force F, it is 500,000 pi Newton divided by pi dt. D is 1000 into T is 10. How much it is coming? 2 into 1000 divided by 4 divided by 10, 50, minus 500,000 pi divided by 1000 divided by 10. It is coming 0. Please check the calculation. Calculation is your partner. 50 minus 500,000. Yes, it is coming 0. Automatically it will come. And in thin cylinder, the radial stress is always negligible, because we neglect the effect, because radial stress is very less, so we neglect the effect of radial stress. Now in the plane in which this sigma C, sigma L and sigma R comes, no shear stress comes. So can I say these are principal stresses? So suppose sigma C I am considering as principal stress sigma 1, sigma L I am considering as principal stress sigma 2, sigma R I am considering principal stress sigma 3. So here the value of sigma 1 is 100 megapascal. The value of sigma 2 is 0. Automatically it is coming, and sigma 3 is also 0. And since examiner is asking as per Tresca's theory, so we'll calculate overall maximum shear stress. Okay. Now for overall maximum shear stress, what is the method? Calculate maximum magnitude out of mod sigma 1 minus sigma 2 divided by 2, comma, mod sigma 2 minus sigma 3 divided by 2, and comma, sigma 1 minus sigma 3 divided by 2. Now calculate all these three magnitude and see which is more. But we had discussed one shortcut trick also to find this. If you want to find out the value which is maximum out of these three, so what is the trick? Out of sigma 1, sigma 2, sigma 3, see which is mathematically maximum. Mathematically maximum is by including sign, and which is mathematically minimum. Then tau max will be sigma mathematically maximum minus minimum divided by 2. If all value are positive, because here positive and only 0 is coming, then the magnitude which is more with plus will be mathematically maximum 100, minus definitely here 0 will be mathematically minimum divided by 2. So how much maximum shear stress is coming? 50 megapascal. Okay. Yes. So now we can calculate factor of safety as per Tresca's, because what is design equation as per this? As per this criteria of failure is maximum shear stress. So maximum shear stress at critical point under actual stress condition, it should be less than the maximum shear stress under tensile test. If tensile strength is SYT, maximum shear stress under tensile test will be 0.5 SYT. Now for design, we'll replace SYT by SYT upon FOS. FOS is factor safety. After that, to find limiting value, we'll use equal to sign. Now tau max is 50, that is equal to 0.5 into SYT tensile strength of the material, it is 380 megapascal divided by factor safety. So from this we can calculate factor safety. How much it is coming? 3.8. You can check the calculation. Very good. So for this question, for mechanical branch, for this question factor safety for is coming 3.8. Okay. Very good. Now moving to next question. Now we'll discuss some question for design against fluctuating load chapter. So you can see we are completing one by one chapter. Okay. So now I'm discussing the question of design against fluctuating load. Okay. What this question is saying, the SN curve on log paper of a material is subjected to completely reverse loading condition as shown in figure. The fatigue strength for 1000 cycle life is 500 megapascal. So fatigue strength for 1000 cycle life is given, and corrected endurance limit of the material is 300 megapascal. Then exam asking fatigue life for fatigue strength is 400 megapascal. So for this fatigue strength, we have to calculate what is the life. Okay, it is simple. So see, this is the SN curve. Now what data is given? See, first of all, fatigue strength for 1000 cycle life is 500 megapascal. I am drawing here. So suppose corresponds to this point, life is 1000. And log 130, it is log of base 10. So log 1000 means log 10 to the power 3 will be 3 and corresponds to this line. Fatigue strength is given. It is 500 megapascal. So can I say this value will be log 500 because here log of fatigue strength we are taking, but whatever log I am taking, it is log of base 10. Now corrected endurance limit is 300 megapascal. See. So what is endurance limit? It is the fatigue strength corresponds to the point where this SN curve is becoming horizontal or asymptotic. So right now it is becoming asymptotic at this point, and this point life is 10 to the power 6 because here 6 is written. So actually it is log 10 to the power 6 now. Log 10 to the 6 is 6 means life is 10 to the 6. But suppose right now it is this value is written, but if it is even not written, okay, then also we'll take life corresponds to this point equal to 10 to the 6. If it is not mentioned, right now it is mentioned, no issue. And fatigue strength corresponds to this will be corrected endurance limit, which is 300. So can I say y coordinate of this point will be log 300 because it is log of fatigue strength of base 10. Okay. Now in this line I know the coordinate of 2 points. Suppose this is point 1 whose x coordinate is x1, y coordinate is y1. This point is point 2 whose x coordinate is x2, y coordinate is y2. So now for this line we can relate the any other point of this line. So for any other point of this line, x coordinate is x or y coordinate is x, y. So I can find the relation between them by interpolation. How? See, all these 3 points are coming in same point. So what is the relation? It will be x minus x1 upon x2 minus x1. That will be equal to whatever pattern we have used with x, use same pattern with y. So it will be y minus y1 upon y2 minus y1. Now x minus x1. x1 is x coordinate of point 1 which is 3. So 3 upon x2, x coordinate of point 2 which is 6 minus x1 is 3 equal to y minus y1. y1 is y coordinate of point 1 which is log 500 of base 10 upon y2, y coordinate of point 2 which is log 300 of base 10 minus y1 is log 500. So see, x minus 3 upon 6 minus 3 is 3 equal to y minus. But here my suggestion is now, whenever you are doing calculation, always do calculation up to 4 to 5 decimal place. This I discussed in the class also. Because na here na at last we need to take anti-log because here I am calculating log of unknown. So at last we need to take anti-log, and wherever we'll take anti-log na variation of answer will be more. So to ensure more accuracy what we'll do? We'll do calculation up to 4 to 5 decimal place in this type of question. So it will be y minus log 500. In calculator, log is log of base 10, 2.69897 divide by, just 1 second, log 300 minus log 500. It is coming minus 0.22184. Okay. So this equation. Now from this equation, if you know x, you can calculate y. You know y, you can calculate x. So see, we have to calculate fatigue life for fatigue strength 400 megapascal. Now log of fatigue strength is coming in y axis. So if I will replace y by log 400, can I say x will be the log of life corresponds to this fatigue strength? Now suppose corresponds to this fatigue strength, life is n dash. So can I say x will be log n dash of base 10. Now log 400 is, I am doing direct calculation because calculation is your part. Log 400 is 2.60206. You can check calculation. So what I am doing, I am replacing y by 2.60206. So x will be log of n dash. So how much log n dash is coming? 2.60206 minus 2.69897 divided by minus 0.22184 into 3 plus 3. Is it coming 4.30810? So n dash, it will be 10 to the power 4.30810. How much it is coming? 10 to the power 4.30810. Is it coming 20328.25 cycles? Check the calculation. 20328. 20440 is also correct. Only ensure you are doing calculation of at least up to 4 to 5 decimal place. Okay. And you can check my calculation also. If I am doing any error, please correct me na. Okay, 20328.25. Only ensure you are doing calculation up to 4 to 5 decimal place, your answer will be within range. Okay. Okay. Now next question. A cantilever, this is also a very good question. A cantilever beam of length 200 mm is subjected to fluctuating transverse load which fluctuates from 400 to 800 Newton. It is shown in figure. Corrected NS limit, yield strength and ultimate strength of the material are 200, 400 and 500 megapascal respectively. Factor of safety is 2. Then examiner asking what is the safe diameter of the beam as per, safe diameter means definitely the cross section is circular of the beam as per Soderberg criteria. So we have to calculate safe diameter as per Soderberg criteria. Now in fluctuating stress condition, now always first find amplitude stress and mean stress at critical. But first I am writing the given data. See what I will do now, write down this load is fluctuating, but to find the stress at expression of stress at critical point now, suppose I am considering this load as P. Actually it is fluctuating from 400 Newton to 800 Newton. But now first consider this as a static load just for calculation, and in terms of P will find the stress at critical point. Okay, definitely in terms of P, stress at critical point will be maximum bending stress in terms of P, because due to transverse load bending stress will come. Okay, so in terms of P will find the stress at critical point. After that what we'll do, we'll replace P by its amplitude value, we'll get amplitude stress at critical point. Well, similarly we'll replace P by its mean value, we'll get the value of mean stress at critical point. But when I'm finding the stress at critical point, we'll calculate in terms of P. Okay. Now corrected NS limit SE is given, it is 200 megapascal. Okay. Yield strength of the material SYT is 400 megapascal. And ultimate strength of the material, that is SUT, is 500 megapascal. Okay, factor of safety is 2. We have to calculate safe diameter as per Soderberg. First I am finding amplitude stress criteria and mean stress at critical point. First I am finding the stress at critical point in terms of P. So since it is transverse load, we will calculate maximum bending stress due to P. Okay. So in terms of P I am finding now. P. First find the expression of maximum bending stress. If cross section is same throughout, the expression to calculate maximum bending stress is mx by z, where mx is maximum bending moment, z is section modulus. Okay. Now cross section is circular whose diameter is d. So expression of z, z is always I by y max na. For circular cross section you can directly remember formula to calculate I is pi by 64 d to the power 4, y max will be d by 2. So to simplify this, it will be pi by 32 d cube. So this is the expression of z. Now what about mx? Mx is maximum bending moment. Yes. Now in terms of P, in cantilever beam na, if transverse load is acting, if that load is trying to bend the beam only in one direction, bending moment will always be maximum at fixed end. So calculate bending moment at fixed end. Now when you calculate bending moment at fixed end, we'll calculate by taking just left and just right of A. Reason, because at a couple reaction can come. So whenever at any point couple is coming, we'll calculate bending moment by taking just left and right of this section. And definitely here we'll calculate bending moment at just right of this section, because at just left there is no material. So calculate bending moment at just right of A. It is nothing but maximum bending moment in terms of P. It will be. Now to find this I am taking right portion. Right portion only one load P is coming. Bending moment due to this will be force P into its perpendicular distance from this section, which is 200. Nature wise it will be hogging, but we have to calculate the magnitude. So I am only writing the magnitude. So magnitude is P into 200. So here maximum bending moment is P into 200 divided by Z. Now if you want, you can put the expression of Z also, which is pi by 32 d cube. But what I am doing now, first our objective is to calculate diameter. Very good dost. But for that what I am doing now, first I am finding the expression of Z, value of Z, because we know the expression of Z in terms of diameter. So once you have calculated Z, from this equation we can calculate diameter also. Or if you want, you can put the expression of Z also here. Z is nothing but I by my max. So in terms of Z, I am writing the equation. So this is maximum bending stress in terms of P. So that I am denoting as sigma. So can I say here the stress at critical point is sigma, which is nothing but P into 200 divided by Z. But P is fluctuating, so it will also fluctuate. In fluctuating, we will find amplitude stress and mean stress at critical point. For that, I am finding the value of amplitude value and mean value of P. So see, this P is fluctuating from 400 Newton to 800 Newton. Maximum value of this fluctuation is 800. minimum is 200. So what will be amplitude? It will be maximum, which is 800, minus minimum 400 divided by 2. It is 200 Newton. What is the mean value of P? It is maximum, which is 800, plus minimum 400 divided by 2. How much it is coming? 600 Newton. Okay. So here in equation 1, if you replace P by P amplitude, we'll get amplitude stress at critical point, and it will be P amplitude is 200 into 200 divided by Z. It is coming 40,000 divided by Z. Similarly, in equation 1, if you replace P by P mean, we'll get mean stress at critical point. How much it is coming? 600 into 200 divided by Z. It is coming 6 2 is 12, 4 times 0 divided by Z. Okay. So now we can use any criteria. Again, asking as per Soderberg criteria. We will draw the graph of Soderberg criteria. See, for a fluctuating stress condition, when we are drawing the graph, in y-axis we take amplitude stress, in x-axis we take mean stress. Now what Soderberg criteria says na? First of all, in Soderberg criteria na, we will draw a line which is known as Soderberg line. How we can draw? As per Soderberg criteria, the criteria of failure in amplitude stress axis is SE, that is corrected energy limit. That you have to remember. In mean stress criteria of failure is yield strength of the material, that is SYT. And if you join this 2 point by straight line, that line is known as Soderberg line. Or actual design is within the region made by this line, that will be safe as per Soderberg criteria. Now to write design equation as per this criteria, first we'll write the equation of Soderberg line. For that we'll use this pattern: x upon a plus y upon b equal to 1. Okay, x upon a plus y upon b equal to 1, where a is x-axis intercept, b is y-axis intercept. Here x-axis means sigma mean axis, and in Soderberg x-axis intercept is SYT, plus y-axis means sigma amplitude, and in Soderberg y-axis intercept is SC equal to 1. But this is the equation of line. Now, but when we are doing designing, we'll take factors of T. So what we'll do, we'll replace SYT by SYT upon FOS, SE by SE upon FS. So FS will come above, you can take common, it will come this side, it will become 1 by FS. So this is design equation as per Soderberg criteria. Now sigma mean is mean stress at critical point, which is 124 times 0 divided by Z, divided by SYT, which is yield strength of the material, it is 400 megapascal, plus sigma amplitude is amplitude stress at critical point, which is 40,000 divided by Z upon SE, which is corrected energy limit, and it is 200 megapascal, equal to 1 by FOS. FOS is factor safety. Factor safety is given 2. So in this equation only one unknown Z is coming, because we can calculate section modulus. How much it is coming? 124 times 0. Z is coming 1000 mm cube, you can check calculation. And Z is pi by 32 d cube, which is 1000. So from this we can calculate d, which is safe diameter of this beam. How much it is coming? It is coming 21.677 mm. You can check calculation. Very, very good. All are correct. So for this beam, safe diameter as per Soderberg criteria with factor of safety 2 is coming 21.677 mm. 21.67. Clear? So this is correct answer for this question. Very good. Now one question I am discussing related to modified Goodman criteria. Try this question. See what this question is saying. This is MSQ. This is also very good question. Means more than one option can be correct. What is saying? The stress at critical point of a specimen fluctuates from sigma to 2 sigma. Ultimate strength, yield strength, and corrected energy limit of the material are 400, 300, and 200 megapascal respectively. Factor safety is 2. Then which one or more of the following option is or are correct? A is saying safe value of sigma as per Langer's criteria. Langer's criteria is also known as yield line criteria, is 75. B saying safe value of sigma as per Goodman criteria is 80. Safe value of sigma as per modified Goodman criteria is 75. D saying safe value of sigma as per modified Goodman criteria is 80. So see, if examiner is asking only with modified Goodman na, then also first you need to find safe value as per Langer and Goodman. Okay. So even if examiner asking only with modified Goodman, then also you have to solve by Langer and Goodman. How? I'm discussing. First of all, question is saying the stress at critical point is fluctuating from sigma to 2 sigma. Okay. Now ultimate strength is 400 megapascal. Yeah, means SUT is given. It is 400 megapascal. Yield strength, that is SYT, is 300 megapascal. And SE, that is corrected error limit, is 200 megapascal. Factor of safety is 2. So we have to find safe value of sigma as per Langer's criteria, also as per Goodman's criteria, and as per modified Goodman. See, first of all, I am drawing the graph of all these three criteria at one place. See, what is Langer's criteria? See, Langer's criteria tells na that material is not failing due to fatigue, it is only failing due to yielding. So that's why na in Langer's criteria, Langer's has drawn a line, but in that line na intercept of both axes is SYT, means as per Langer's, intercept in sigma amplitude axis is also SYT, that is yield strength. In mean stress axis also intercept is SYT, that is yield strength. Why? Because it is assuming material is only failing due to yielding, it is not failing due to fatigue. And this line is known as Langer's line. Okay, suppose this line is 1, it is known as Langer's line. And if actual design is within the region made by Langer's line, that will be safe as per Langer's criteria. If exam asking only with Langer's criteria, design, this is sufficient. But now Goodman, what is Goodman? As per Goodman, again graph is straight line, but it tells that in amplitude stress axis, criteria of failure is SE, that is corrected error limit. Definitely SE will be less than SYT, so it will come same here. And criteria of failure in mean stress axis is always SUT as per Goodman, means ultimate strength. And ultimate strength will be more than SYT, that's why it is coming here. And if you join this 2 point by straight line, that line is known as Goodman line. Okay. So if examiner is only asking with Goodman, this is sufficient. Okay. And actual design is within the region made by Goodman line, that will be safe as per Goodman criteria. Now what is modified Goodman? That is important. Okay. See, modified Goodman is nothing but the safer criteria between Langer and Goodman is modified Goodman. Means for modified Goodman, how you can remember? The safer between Langer and Goodman is modified Goodman. That is sufficient. Like here in this graph na, if you see, do analysis in this region na, Goodman is more safer because this region safety is less. So in this region, Goodman result is modified Goodman. In this region, Langer is more safer because this region safety is less. So in this region, Langer is modified Goodman. This is safe region as per modified Goodman criteria. Okay. But when you are solving by modified Goodman na, you need not to find this region. Simply what you can do na, you need not to find whether actual stress is this side or this side. Simply na, whatever exam asking, calculate that unknown by Langer also, calculate that unknown by Goodman also, and out of that two result, whichever is safer result, that will be result by modified Goodman. And how will find which is result? So generally two type of question will come. One is the question will come in which examiner will ask factor of safety. In this question, examiner not asking factor of safety, but suppose design is completely given and examiner asking factor of safety. So with more safer criteria, na, FOS comes lesser. This we have discussed in the class. So what we'll do, we'll calculate FOS by Langer, FOS by Goodman, whichever is coming less, that will be more FOS by modified Goodman. But if FOS is given, like here FOS is given, and it is the question of design. Design means we are calculating some unknown, whether it is load, whether it is a diameter. So just remember one thing, more safer criteria gives more strong design. More strong means actual unknown will be less. Actual stress will be less. Okay. More safer design, more strong design. More strong means actual stresses will be less. Now when actual stress will be less, whether it is amplitude or mean, that will depend upon unknown. Suppose we are calculating unknown x. Actual stress equation is such that actual stress will be less when x is less. So with more safer criteria, x will come lesser. So calculate x by Goodman, calculate x by Langer, whichever is less, that will be x by modified Goodman. But suppose equation is such that actual stress will be less when x is more. So with more safer criteria, x will come more. So calculate x with Langer, calculate x with Goodman, whichever is more, that will be modified Goodman. So like this you can do analysis. Here, first I am finding the expression of amplitude and mean stress. Here sigma is unknown, so automatically it will come in terms of sigma. The mathematical max value of fluctuation is 2 sigma, minimum is sigma. Now amplitude will be maximum, which is 2 sigma minus minimum sigma divided by 2. How much it is coming? 0.5 sigma. Mean will be maximum 2 sigma plus minimum sigma divided by 2. How much it is coming? 1 by sigma. Like asking sigma as per Langer we can calculate, as per Goodman we can calculate. But for modified Goodman, what we can conclude? Can I say with more safer criteria, here sigma will come lesser? Because actual stress will be less when sigma is less. So here less is more safer. So we'll calculate sigma by Langer, sigma by Goodman. Whichever is coming less, that will be sigma by modified Goodman. I think it is clear. That will be sigma by modified Goodman. But for that, first I am finding by Langer and Goodman. Okay. So as per Langer's criteria, what will be the design equation? First write the equation of Langer line. Here both axis intercept is SYT na. So here x axis means sigma mean upon, in Langer's x axis intercept SYT plus y upon b. Y axis means sigma amplitude. In Langer y axis intercept is also SYT equal to 1. Now for design we will take factor safety, so we will replace SYT by SYT upon FS, SYT by SYT upon FS. FS will come common. It will come this side, it will become 1 by FS. Now sigma mean is 1.5 sigma upon SYT. Yield strength it is 300 megapascal. Plus sigma amplitude is 0.5 sigma upon SYT is again 300 equal to 1 by factor of safety, which is 2. So how much sigma is coming? As per this, it is coming 300 by 2. It is coming 75 megapascal. So as per Langer's criteria, can I say safe value of sigma is 75? So option A is correct. Now as per Goodman's criteria, see in Goodman's, first write the equation of Goodman line. Again x upon a plus y upon b equal to 1. X axis means sigma mean, upon Goodman x axis intercept is SUT plus y axis means sigma amplitude. In Goodman y axis intercept is SE, that is corrected and its limit equal to 1. Now for design we will replace SUT by SUT upon FS, SC by SC upon FS. FS will come common, it will come this side, it will become 1 by FS. Now sigma mean stress at critical point 1.5 sigma upon SUT ultimate strength which is 400 megapascal plus sigma amplitude 0.5 sigma upon S is 200 equal to 1 upon factor of safety, which is 2. So how much sigma is coming? It is coming 80 megapascal. You can check calculation. So safe value of sigma as per Goodman criteria is 80. So B is also correct. Now next we have to calculate safe value of sigma as per modified Goodman. We know safer result out of Goodman and Langer is modified Goodman. Now here we are calculating sigma na. So it is the question of design. And we know more safer result gives more strong design. More strong means actual stress will be less. When actual stress will be less, whether it is amplitude or mean, when sigma is less. So here less is more safer. So we will calculate safe value of sigma as per Langer, safe value of sigma as per Goodman, and out of these two, whichever is less, that will be safe value of sigma as per modified Goodman. So less is 75. So for this question, safe value of sigma as per modified Goodman is 75. Very good. Okay. So C is correct, D is incorrect. So for this question, the correct options are option A, B and C. Very, very, very good. Clear? Yes. So we have completed the question of design against fluctuating load also. Now going to next chapter, welded, bolted and riveted joint. Okay. Like solve this question. This is numerical answer type question. Huh? First of all, I am reading the question. Two plates of thickness 12 mm each are joined together by transverse fillet weld on one side. Here it is transverse fillet weld. And resulting structure is loaded as shown in figure. Now the ultimate shear strength of the weld material is 200 megapascal. It is shear strength, na? And factor of safety is 2. Then as per maximum shear stress theory, even see in question if shear strength is given, we will always solve by shear stress theory. The minimum length of the weld required to ensure that weld does not fail. This is good question. Okay. So simply you can remember in transverse fillet weld means if force is perpendicular to weld length. Here if you draw a line along weld length, you can see force is perpendicular to this line. That's why it is transverse fillet weld. In transverse fillet weld, in the weld, due to force, both direct normal and shear stress comes. The formula to calculate direct normal stress is also force upon throat area. It is not actual formula, it is approximate formula. But in weld design, we directly use this formula. Formula to calculate direct shear stress at critical point is also force upon throat area. So here both normal and shear is coming, and formula to calculate maximum normal stress due to force is also force upon throat area. For shear stress also formula is force upon throat area. Okay, now during design, I will take this weld in normal or shear. That is important because student get confused in this. So this I discussed in the class. If in question permissible normal stress is given, then I will consider transverse fillet weld is in normal, and formula to calculate normal stress is force upon throat area. If permissible shear is given, then I assume it is in shear, and formula to calculate permissive shear stress in the weld is again force upon throat area. So here shear strength of the material is given. Even examiner is saying use shear stress criteria, but even that is not written. If shear strength is given, we will consider this is in shear. And if you are considering this is shear, the formula to calculate maximum shear stress or direct shear stress is force upon throat area. So here I will take this weld in shear. Before that, I am writing the given data. See, thickness of each plate is 12 mm. So can I say here it will be the size of the weld? Why? Because this thickness is 12 mm, and in this weld you can see this thickness is nothing but size of the weld. This dimension is known as size. Size of the weld I am denoting as H. It is 12 mm. In throat plate weld always calculate throat. Throat will be H by root 2. H is 12 divided by root 2. So how much throat thickness is coming? 12 divided by root 2. It is coming 8.485 mm. Okay, good. Now the shear strength of the weld material is given. It is 200 megapascal. Suppose that I am denoting as tau wave. Directly shear strength is given. Factor of safety is 2. Examiner is saying use shear stress. Use shear stress criteria means we have to calculate maximum shear stress. Even if that law is not written and shear strength is given, we'll always calculate maximum shear stress. Okay. What is the length of the weld required? Okay. So here it is transverse fillet weld. Suppose length of this weld is L. Only one weld is coming and length of this weld is L. Okay. So here we'll consider this in shear because we have to use shear criteria. Okay. Yes. Yes. Throat size of the weld is 12. Na? So throat will be H by root 2. Calculate throat. Yes. 12 divided by root 2. Yes, it's correct. So see, the formula to calculate direct shear stress in transverse fillet weld is force upon throat area. Suppose this force I am denoting as P. It is 6 kilonewton in Newton, 6000 Newton. So you can directly use force upon throat area. Force is 6000 Newton. Now throat area, it will be throat thickness into length of the weld. Throat thickness is T, which is 8.485 mm into length of the weld is suppose L. Okay. Now apart from this, no other shear stress is coming. So it is also overall maximum shear stress. For design, it should be less than equal to shear strength of the material. Yes, tau. Shear strength is tau wave. Now for design, we'll always replace shear strength by shear strength upon FOS. After that, to find limiting value, we can use equal to sign. So since I am finding limiting value, we can use equal to sign. Now it will be 6000 upon throat area 8.485 into L is equal to shear strength is 200 megapascal and factor safety. Factor safety is given, I think. Na? Factor safety is given, it is 2. Length we have to calculate. So factor safety is 2. So how much safe length of the weld is coming? 6000 divided by 8.485 divided by 100. Is it coming 7.071? Actually, it is coming very lesser. I think there is some typing error. Actually, it was 60 kilonewton. But suppose same question is coming in gate by 6 kilonewton, you put this answer, whatever it is coming. But actually, length will come most of the length will come more than the thickness. But if suppose it is 6 kilonewton, put this as your answer. Don't think too much in gate examination because whatever data is given as per that we will do calculation. Na? But since I am taking the class in YouTube, I can resolve this typing error. It is just typing error. Actually, it was 60 kilonewton. Okay. 60,000 Newton. Okay. So this is just typing error. So just I am increasing 1 0. So it will be, actually it is 70.71. But as per 6 kilonewton, 7.071 is correct without any doubt. But actually it was 60. So it is coming, as per that data, it will be 70.71. Now it is 70.7. If you are taking 6, then it is 7.071. Okay. So this is correct answer. Very good. Rohan, Madhu, very good Vibhu. Because as per 6, your answer is correct. Now going to next question, solve this question. This is circumferential weld, na? See, whenever diameter is given, so in diameter, it is circular section. In circular section, only circumferential weld is possible. So this weld is like this. If you draw the side view of weld, it will be like this. Now solve this. The figure shows the cross section of circular fillet weld joining cylindrical pin to a steel plate. it is subjected to torsional load. The value of that load is given. Then exam asking what is the shear stress in the throat of the weld or torsion shear stress. So we have to calculate torsion shear stress in this weld. See, first of all, now this moment is torsion moment for weld. How you can prove that? See, I am solving this question. Circumferential weld. Suppose I am drawing the side view of the weld. It will be like this. Inside view, I am drawing the diagram of weld is line. Whenever we have to use thickness of the weld in a stress calculation, we will take throat thickness because that is critical value. Okay. But now our assumption is that diameter thickness is very less as compared to diameter or radius of the weld. Right now, the diameter of the weld, you can see it is, see, diameter of this pin is 0.3 meter. In mm, it will be 300 mm, yes or no? So can I say radius is half of 300, that is 150 mm. Now actually it is inner radius of weld, but we are assuming that radius is very high as compared to thickness. This is by default assumption in circumferential weld. Na? So I am simply saying the radius of this weld is 150 mm, whether it is inner, outer or mean, because whenever we have to put the separately the value of radius only, I will put radius equal to this, because inner, outer, mean all are near to each other. So radius is 150 mm. Now next we require throat thickness. So see here the size of the weld is given, again 0.01 meter. In mm it will be 10 mm, yes or no? It is size of the weld because this thickness is known as size of the weld. And if size of the weld h is 10 mm, what is throat thickness? Because for stress calculation, calculate throat thickness. So throat thickness T will be h by root 2, yes sir. H is 10 divided by root 2. So how much throat is coming? 10 divided by root 2, that is 7.071 mm. Now in this weld, whose throat thickness is this, radius is this, we have to calculate shear stress due to torsion. Now why it is torsion for the weld? Because in weld we are calculating the stress. So whenever any moment is acting about the axis which is perpendicular axis of this plane of weld, this is known as plane of weld, that will be torsion moment. Due to that torsion shear stress will come. If moment is acting about along axis of plane of weld, that will be bending moment. Due to that bending stress will come. So why it is torsion? Because see, this torsion is acting about this axis. Suppose this is z axis. Now this is perpendicular axis of the plane of weld, because plane of weld is like this, and for this plane of weld perpendicular axis is this. Here it will show z axis, it will look like a point, na? Because it is perpendicular axis of this weld, and this torsion moment is acting about this axis. So that's why it is torsion resistance for weld also 5 kilonewton meter. In Newton mm it will be 5 into 10 to the 6 Newton mm. Why? Because it is acting about z axis which is perpendicular axis of the plane of weld. Okay. Now due to this I want to calculate torsional shear stress. Now examiner whether exam saying calculate torsional shear stress, we will always calculate maximum torsional shear stress, because okay, and formula to calculate this is torsion moment T upon JCW, which is polar area velocity of the weld about centroid, into R max, means maximum radial distance from centroid. If you want, you can simplify this. For circumferential weld, formula to calculate polar area velocity is 2 pi T R cube, where T is throat thickness, R is radius. Now what is R max? R max is maximum radial distance from center. Actually it will be at outer layer, which will be equal to R naught, outer radius, but Ri, R naught, R all are near to each other. So I can take R max equal to R also. One R will get cancelled, so it will be 2 upon 2 pi T R square. Now T is torsion resistance, which is 5 into 10 to the 6 Newton mm upon 2 pi T. T is 7.071 into R square. R is 150, so 150 square. So how much maximum torsion shear stress is coming? 6. Sorry, it's square, na? Is it coming nearly equal to 5 megapascal? Yes. So torsion shear stress in this question is 5. What mistake you have done? 5. So for this question, the correct answer is option B. You will get answer as A, na? See, you write this silly mistake. But now this mistake you will not do in GATE exam. I am 100% sure. Here we will always take throat thickness, but in question it is the size of the weld. So write this in your mistake copy, na? You will not do this mistake in actual GATE exam then. Okay, so for this question option, this is real MCQ question. Even you are doing some mistake, you are getting other option as your answer. So mistake is not allowed. Okay, for this question correct answer is B. Now next, I am discussing some question related to bolted joint. Solve this question. This is multiple choice question. what this question is saying, a bolted assembly is tightened by half rotation of nut, pitch of the thread is 1 mm, stiffness of bolt is 150 meganewton per meter, and stiffness of connecting member under compression is 100 meganewton per meter. Then what is axial force in bolt due to tightening? Due to tightening, first of all, preloads come. Suppose that preload I am denoting as Pi. So what is the axial force of bolt? I am asking preload. If you know that effect of preload on bolt is always tensile, and connecting member it is compressive. So examiner asking in bolt na, so it will be tensile. So you can directly eliminate option B and D. Now out of A and C, which is correct? That for that we have to do calculation. See, first I am discussing how you can solve this type of problem. What data is given? We are tightening the bolt by half rotation. So number of ton of nut during tightening is half ton. Now pitch of the thread is given. It is 1 mm. We require lead. Okay. See, it is not mentioned whether thread is single start, double start or triple start. So we'll always assume if it is not given, thread is single start thread. Or for single start thread, the lead is equal to 1 times of pitch. Now pitch is 1 mm. So 1 into 1 lead is 1 mm. Okay. Now stiffness of bolt is given. It is 150 meganewton per meter. Stiffness of connecting member KCM is given. It is 100 meganewton per meter. Okay. Now see, examiner asking preload ultimately in kilonewton, and these data are given in mm. So what I am doing now, I am first decide the unit. During calculation, I will take force in kilonewton, distance in mm. So convert this also in kilonewton per mm. So it is 150 meganewton. 1 meganewton is 10 to the power 3 kilonewton. Divided by below side meter is coming. 1 meter is 10 to the power 3 mm. So it is in kilonewton per mm. 10 to the 3, 10 to the 3 will get cancelled. So automatically it is coming 150 kilonewton per mm. But do this conversion. Similarly, if we convert this also, again I will get 100 kilonewton per mm. So indirectly we have to calculate preload, because axial force in bolt due to pre-tightening will be equal to preload. See, for this type of problem now, you can remember, suppose this is bolt, FBD of bolt, and with this yellow color I am showing connecting member. See, due to tightening now, this we have discussed in the class, due to tightening, connecting member will always compress. So what will happen? Suppose due to tightening, the load which is coming is Pi. So the nature of Pi in connecting member will always be compressive. Okay. And by whatever amount compressive force is coming in the connecting member, the tensile force by the same amount will come in the bolt to ensure net force in axial direction is 0. So if preload is Pi, the nature of that Pi in connecting member is always compressive. The nature of that Pi in bolt is always tensile. Okay. Or if examiner, sometimes examiner can ask directly, simply calculate Pi. The nature of that Pi is bolt is tensile, connecting member is this compressive, that we know. So how will calculate this Pi? So for this Pi now, if you know how much we are tightening the nut during tightening, suppose the axial displacement of nut during tightening is X. What is X? X is the axial displacement of nut during tightening. Now this will always be equal to the elongation of bolt due to tightening, because due to tightening bolt is in tension, and compression of connecting member due to tightening. We have to add both of them. That's why I am saying with nature, it will be equal to elongation of bolt due to tightening plus compression of connecting member due to tightening. Why? That we are discussing in the class now. Now if axial force is Pi, so its nature in bolt also it is Pi tensile. So can I say elongation of bolt will be Pi upon Kb, stiffness of bolt is Kb. Now axial force in connecting member is compressive Pi, so it is already compression of connecting member. So you need not use minus Pi upon Kc. Why I am not using minus? Because it is compression of connecting member. But sometimes my student are having habit, for tensile we use plus, for compression I use minus. That's why I am writing this with mod. So even by mistake here you will write minus because it is compressive. Then also no issue, because if I will take the mod of this, minus will get removed. Because we have to add the magnitude of both of them, that is equal to X, which is axial displacement on it during tightening. Right now in question X is given, Kb is given, Kcm is given, we can calculate Pi. Because see now X is equal to Pi upon Kb. If we bring outside root, it will be plus Pi upon Kcm. Now, X is given how? See, during tightening, the axial displacement of nut will be, lead is L, during tightening number of ton is L. Now, what is lead? It is the axial displacement for 1 ton. So, if axial displacement of 1 ton is L, axial displacement on n ton will be NL. So this is axial displacement not during tightening. N is half, lead is 1. How much it is coming? 0.5 mm. Okay. Just 1 second. Yes. So x is coming 0.5 mm. So just put here 0.5. Pi I am taking common is equal to 1 upon kb. Kb is 150 kilonewton per mm plus 1 upon kcm. Kcm is 100 kilonewton per mm. So from this we can calculate Pi. It will come in kilonewton because we have taken force in kilonewton. How much it is coming? It is coming 30 kilonewton. And we know nature of preload in bolt will as well as tensile. So can I say axial force in bolt due to preload is 30 kilonewton? Its nature it is tensile. If exam asking connecting member, it is again 30 kilonewton but nature compressive. But in bolt it is 30 kilonewton tensile. Matching with which option? Option A. So A is correct, C is also incorrect. So for this question the correct answer is option A. Very, very, very good. Okay. Now this question actually na diagram is also there. Draw this diagram also na. Now solve. Two flat plates subjected to a tensile force P are connected together by means of single riveted lap riveted joint as shown in figure. Diameter of rivet 10 mm, diameter of rivet hole 11 mm, width of each plate 200 mm, thickness of each plate is 5 mm. Allowable tensile stress of plate 120 megapascal, allowable shear stress of rivet is 80 megapascal, allowable crushing stress of rivet is 160 megapascal. Then which one or more of the following option is your correct? Since it is MSQ, more than one option can be correct, so you have to focus in all the options. In option exam asking tearing load capacity means load capacity to avoid tearing failure. B shearing load capacity, C actual load capacity, C crushing, B C crushing load capacity, and D actual load capacity. Even to find actual load capacity, you need to find tearing, shearing, and crushing load capacity. And what is actual? Actual load capacity is lesser value out of tearing load capacity, that is PT, crushing load capacity, that is PC, shearing load capacity, that is PS. So even to calculate actual load capacity, first you need to find PT, PS, which is shearing load capacity, and PC, which is crushing load capacity. Solve this. See, I am also discussing na. This is the diagram. Okay, diagram is also there. Now, two flat plates subjected to tensile load by means connected by means of single riveted lap joint. The diameter of rivet is 10 mm. Suppose that I am denoting as D. So it is 10 mm. Diameter of rivet hole is 11 mm. So it is also given DH. It is 11 mm. The width of each plate. Suppose width of each plate I am denoting as W. So it is 200 mm. Thickness of each plate. Suppose that I am denoting as T. It is 5 mm. And allowable tensile stress of the plate, that is sigma TP, is given. It is 120 megapascal. Allowable shear stress of the rivet tau P is given. It is 80 megapascal. And allowable crushing stress of the rivet once is, that is sigma CP, is given. It is 160 megapascal. Okay. We have to find first tearing load capacity, second shearing load capacity, third crushing load carrying capacity, and fourth actual load capacity is minimum out of all type of load carrying capacity. Okay, now doing calculating one by one. Suppose first we are calculating tearing load capacity. What is the method to calculate this? See, tearing load capacity means load capacity to avoid tearing failure. Load capacity to avoid tearing failure. In tearing failure, tensile failure occurs. Na? So since we are calculating tearing load carrying capacity is not actual load. Actual load should be less than equal to this to avoid a tearing failure. So what we will do to calculate this capacity, will equate actual tensile stress with permissible, that is sigma TP, and we will multiply this with tearing area, Now, what is the method to calculate tearing area? That is very important. So, what we'll do now? Consider any plate. If width and thickness of both of plate are same, you can consider any plate. So, what suppose I am considering plate 1. So, see which row is nearest to load P of plate 1. This row. So, in this row now, if plate is it is occurring in plate. Plate is tearing from this plane. So, what will happen now? This portion of plate 1 will get separate. Means this failure will occur. So, to avoid tearing failure, I don't want tearing from this plane. So, that's why the area of the plate in this plane is known as tearing area. And what is the effective area of the plate in this plane? So, total width is W. But you can see in this plane, there is 3 hole. Because if there is 3 rivet, means hole actually it is in plate actually it is hole na. So, here 3 hole will also come. So, to find effective width of the plate, we need to subtract diameter of 3 hole. So, effective width will be W minus 3dh into thickness of the plate is T. So, for this question, this is tearing area. It is W minus sigma Tp into W minus 3dh into T. Now, sigma Tp is permissible tensile, which is 120. W is 200 minus 3dh is 11 into thickness of each plate is 5 mm. Calculation is your part. How much it is coming? 120 into 200 minus 3 into 11 into 5. It is coming 1,002. The tearing load carrying capacity is 100.2 kilonewton. So, option A is correct. Now, shearing. Now, what is the method to calculate shearing load capacity? Options are given in terms of pi now. So, I will calculate in terms of pi. See, to calculate shearing load capacity, first equate actual shear stress of rivet with permissible into. Now, we'll multiply this with total shear area. Now, what is the method to calculate total shear area? For that, first calculate shear area of one rivet. I am writing the formula, then I will explain. Shear area of one rivet will always be pi by 4 d square into s. What is s? I will explain. Into number of rivets per plate. Number of rivets per plate. Suppose generally I denote this as capital N. First of all, what is total number of rivets per plate? So, in lap joint, it is very easy. In lap joint, take any plate. Suppose I am taking this plate. How many rivets are there? 3. So, here number of rivets per plate is 3. But in pi by 4 d square into s, what is s? S represents number of shear. Number of shear means if in one rivet shear is occurring in one plane, s will be 1. If it is occurring in 2 plane, s will be 2. So, that you can do analysis here. It is lap joint. So, here when shear failure will occur in this one rivet, only focus in one rivet, it will fail from this plane. Means here shear is occurring from one plane. So, here it is subjected to single shear. So, s will be 1. Okay. So, what is tau p? It is 80 megapascal into pi by 4 d square, d is 10. So, 10 square. Since it is subjected to single shear, s is 1 into number of rivet per plate is 3. How much it is coming? First, I am calculating in terms of pi. 80 divided by 4 into 10 square into 3. Is it coming 6000 pi Newton? In kilonewton, it will be 6 pi kilonewton. In points, it is 18.85 kilonewton. Okay. So, 6 pi kilonewton or 18.85. Okay. In both B, C, same value is rated. Don't say it was 18.85. So, it is 6 pi. See, complete. 6 pi is correct, na? So, B is also correct. Very good. Now, next we have to calculate crushing load capacity. It is very easy. You can actually remember the formula to calculate this. See, crushing load capacity is always first equate actual crushing stress with permissible, which is sigma Cp, into total crushing area. Total crushing area. First, write the expression of crushing area of one rivet, which is d into t. This formula you have to remember. D is the diameter of rivet, t is thickness of each plate, and dt is nothing but crushing area of one rivet. And multiply this with the capital N, that is number of rivet per plate. Now, sigma Cp, it is given in the question. Sigma Cp is 160 into d 10, t 5, number of rivet is 3. So, how much it is coming? 160 into 10 into 5 into 3, it is coming 24,000 Newton. In kilonewton, it is 24 kilonewton. So, for this question, the value of crushing load carrying capacity is 24. So, C is also correct. Now, D is actual load carrying capacity. Okay. So, actual load carrying capacity is minimum out of PT, PC and PS. Now, this is 24. It is 6 pi or 18.85. So, out of these two, 18.85 is lesser. Now, means 6 pi is lesser. It is 100.2. So, out of all these three value, can I say 6 pi or 18.85 is lesser? So, for this question, the actual load carrying capacity is 6 pi kilonewton. Okay. But actually na examiner has taken maximum out of these three, but actually it should be minimum out of these three. So that's why option D is not correct. So for this question, the correct options are option A, B, and C. C is also correct, Madhu. Okay. So these are the correct options. Okay. Now moving to next question. Solve this question. This is also very good question. Again, it is MSQ. What this question is saying? A bracket is fitted to a channel by means of two identical rivet as shown in figure. Which one or more of the following option is or are correct for the worst loaded rivet? Worst loaded means for critical rivet. So whatever option are given, it is for critical rivet. Exam asking what is primary shear force in critical rivet, secondary shear force in critical rivet, and resultant shear. If exam asking actual shear force, means we have to tell resultant shear force. If exam asking actual shear stress in any rivet, that is again resultant shear force divided by area of, okay. But right now examiner is not asking stress, only force. So primary shear, even to calculate resultant, you need to first find primary and secondary. But here most important, which rivet is critical rivet, because we have to do calculation for worst loaded. What we'll do now, suppose this load is P, it is 20 kilonewton. Okay. Examiner is also asking in kilonewton, so I'm taking this force in kilonewton. So what I'm doing, I'm taking force in kilonewton, distance in mm. Now first we'll transfer this load P in the combined centroid of the rivet. See, this is the center point of rivet 1. This is the center point of rivet 2. Both are coming in same horizontal, and if I will draw separately, it will be like this. This is center point of rivet 1, center point of rivet 2. Distance between them is 100 mm. All dimensions are in mm, that I will not write again and again. Okay. Now its combined centroid will be at middle, because both rivet 1 and 2 are coming in same horizontal line. So this is centroidal x-axis. Its centroidal y-axis will also be at middle, because about centroidal middle y-axis, it is symmetric, because whatever pattern of rivet I am getting this side, same pattern I am getting this side. So this symmetric y-axis is centroidal y-axis, with this distance are 50. And intersection of these two axes is nothing but the combined centroid of this rivet. So can I say here combined centroid is coming somewhere here, C dash. This is also 50. Now we'll transfer this load P at C dash. So when you transfer, definitely here one direct force P will come, no doubt. But about C dash, due to P, one moment will also come. That moment will be P into its perpendicular distance from C dash. P is vertical, so horizontal distance. Horizontal distance is 250 mm. Suppose this distance I am denoting as E. So moment will be P into E. But at C dash, it will act like this, because this force is rotating at C dash like this. So moment which will come at C dash will be clockwise like this, P into E. And it is acting about this axis. This axis I am referring as Z axis, which is perpendicular axis of the cross section of rivet. So when we have transferred this load P at C dash, one direct force P is coming like this, one moment is coming P into E like this about Z axis. In direct force P is 20 kilonewton. Now in moment P into E, P is 20 kilonewton and distance E is 250. So this much of kilonewton mm. But see, here if you see this direct force P, it is parallel to the cross section of rivet. Take any rivet, it is parallel to the cross section of rivet. So this will act as shear force for the rivet, and due to this direct or primary shear stress or force will induce. So can I say due to P, primary shear will come in the rivet, and we know primary shear is same in each rivet. Formula to calculate primary shear force is, first we'll calculate as force na, is total load P divided by number of rivet. But that is different thing, but it will be same at each rivet. But what about this moment? This moment is acting about Z axis, which is perpendicular axis of the cross section of rivet. So it will act as torsion moment. And due to torsion, torsional or secondary shear will induce. Okay. So here due to moment, secondary shear will induce. Okay. And this secondary shear is proportional to RA. What is RA? RA is radial distance of center of any rivet from centroid. If RA is more, secondary shear will be more. Okay. And since both are shear, they will have some resultant shear. And exam asking this primary shear, secondary shear, and at last resultant shear for critical or worst loaded rivet. Now, how will I identify which rivet is critical? That is important. So for that, what is the method? Now, in this diagram, first mark farthest rivet of all side, because for farthest rivet RA will be more, means secondary will be more. But if secondary is more, chances that resultant will be more will increase. But resultant will depend upon vector angle also, na. If the suppose you are taking two vector 100 and 200, but if vector angle between them is less, suppose 0, then resultant will be 300. If vector angle is more, suppose 180, resultant will be 300, 200 minus 100, that is 100. Means if vector angle is less, resultant will be more. So here resultant depends upon for which rivet resultant will maximum, that will depend upon for which rivet secondary is more, it will be more when Ri is more, but second for which rivet theta, that is vector angle, is less. So for that, what is the step now? First of all, mark farthest rivet of all sides. Like for this side, from this draw x-axis and y-axis, farthest rivet is 2. Similarly, for this side, farthest rivet is 1. For this side again, farthest rivet is 1. For this side also, farthest rivet is 2. So 1 and 2 are coming into picture. So if I am marking farthest rivet for all sides, 1 and 2 are coming. Now we have to find out of 1 and 2, which rivet is overall critical rivet or worst loaded rivet. So for that, what we'll do? For this rivet 1 and 2, we'll calculate two things. First, Ri. Ri is radial distance of center of that rivet from center. We will see for which rivet Ri is more. Second, theta. Theta is vector angle between primary shear and secondary shear. And we'll see for H angle, vector angle is lesser. Okay. And the rivet out of 1 and 2 for which Ri is maximum, theta is minimum, that will be critical rivet. Ri calculation is easy. Ri is radial distance of center from centroid. For rivet 1, this radial distance of center of rivet 1 from centroid is 50. So R1 is 50 mm. For rivet 2 also you can see it is 50 mm. So as per Ri criteria, it is same for both rivets. So you can take any rivet out of 1 and 2. But what about theta criteria? For that, I need to draw primary shear and secondary shear for both the rivet. First, I am drawing primary shear. I am drawing as a force. Primary shear will always be opposite to P. P is downward, so it will be upward. So this is primary shear force of rivet 1. I am representing as P S1 dash. S for shear, 1 for rivet 1, and above said dash. For above said, I will take dash for primary and double dash for secondary. So since it is primary, I am taking dash. Similarly, P is downward, so it will be opposite. This is primary shear force of rivet 2, that is PS2 dash. Now for secondary, suppose first I am drawing for rivet 1. What is the method? Join center of rivet 1 with centroid. This line is coming. Secondary will always be perpendicular to this line because it is coming due to movement. It is horizontal, so perpendicular of this will be vertical. Now sense, in this line will take such sense which will rotate this point about C dash in the direction opposite to movement. Right now movement is clockwise. So take such arrow which will rotate this point about C dash in anti-clockwise direction. To rotate this point about C dash in anti-clockwise, I need to go like this. For that, we'll take arrow this side. So this is PS1 double dash secondary shear force of rivet 1. Similarly, to draw secondary shear for rivet 2, join center with centroid. This line is coming. Perpendicular to this line is again vertical. Now in this line, we'll take such arrow which will rotate this point about C dash in anti-clockwise. To rotate this point about C dash in anti-clockwise, I need to go like this. For that, we'll take arrow towards this side. This is PS2 double dash. So see, if we'll rivet 1 now, here primary and secondary are opposite, means vector angle is 180. Here primary and secondary are coming in same direction. Same direction means vector angle is 0 and vector angle cannot be lesser than 0. So can I say here vector angle is coming minimum for rivet 2 out of 1 and 2. So as per this, 2 is critical. So common rivet is 2. So here 2 is overall critical. Sometime 1 mark question can come in which examiner will ask only which rivet is critical rivet, or critical means worst loaded rivet. And for this rivet, we have to calculate primary, secondary and resultant. First I am calculating primary shear force on worst loaded rivet means rivet 2, that is PS today. But primary shear, see, it will be same for each rivet. So same value will come for critical rivet also. And formula to calculate this is total force, which is P divided by number of rivet, which is 2. Right now P is 20, so 20 divided by 2, 10 kilonewton. So primary shear force is 10 kilonewton. Now secondary. So now I am calculating secondary shear force on critical or worst loaded rivet 2. So that is PS2 dash. Now double dash for secondary. What is the formula to calculate secondary shear force of any rivet? It is 1 proportional cluster C into Ri of that rivet. For rivet 2, Ri is R2. But here what is the formula to calculate C? So see, in secondary shear for calculation, the formula to calculate this proportional cluster C is the moment due to which secondary shear is coming. In this case, it is P into E upon summation of Ra square. So for C calculation, I need to calculate Ra of all the rivet because below side we have to take summation of Ra square into above R2 because we are calculating secondary shear force of rivet 2. Now out of P into E, P is 20 kilonewton, E is 250 divided by Ra square. Here 2 rivet are coming now, 1 and 2. So it will be R1 square plus R2 square. R1 is 50, so 50 square plus R2 is also 50, so 50 square into above side R2, which is 50. So from this we can calculate secondary shear force of worst loaded rivet. How much it is coming? 20 into 2000 divided by 50 square plus 50 square into 50. Is it coming 50 kilonewton? Okay. Why you are taking root over? Simply see vector angle between them. If vector angle is 0, directly add them. If it is 180, means opposite, directly subtract them. If they are coming in 90, then vector angle is 90, then resultant will be root over square plus this square. If vector angle is other than 90, other than 0, suppose that vector angle is theta, then you can use the formula. Formula is to calculate resultant is root over PS2 dash square plus PS2 double dash square plus 2 PS2 dash PS2 double dash cos theta. This we are discussing in the class, where theta is vector angle between primary and secondary. But here even this formula is not required. Directly you can calculate, because it will calculate resultant shear force of rivet 2. Resultant. And whatever resultant shear force is coming for rivet 2, that is also overall maximum shear force. Reason? Because it is resultant shear of critical rivet. And here can I say to calculate this, just add primary and secondary. Reason? Because in rivet 2 both primary and secondary are coming in same direction. So resultant just add them. Now primary is 10, secondary is 50. So how much it will come? 60 kilonewton. This is also very good. So resultant shear force of worst loaded rivet is 60 kilonewton. Okay. So primary is 10, A is correct, secondary 50, B is correct. It is coming 60 now, so C is incorrect. 60 is coming for D. See, resultant is 60, so D is correct. Okay. So for this question, correct options are option A, B and D. Clear? So we have completed welded, bolted and riveted joint also. Okay. Now I am going to start the question of bearing. See, this is the question of rolling contact bearing. What this question is saying, a deep groove ball bearing is subjected to radial force of 20 and thrust means axial load of 10 kilonewton. Radial factor is 0.56, thrust factor is 1.2. Dynamic lead carrying capacity of the bearing is given, it is 40 kilonewton. Then what is the rated life of the bearing in MR? Exam asking rated life of the bearing. It is simple formula based question. See what this question is saying. In a groove ball bearing, the radial force, suppose that I am denoting as FR, is 20 kilonewton. Axial force FA is 10 kilonewton. Now since if both radial and axial load is coming now, we'll convert that into equivalent load that we represent as P. Okay, for equivalent load this factor are given. Radial factor, so that I am denoting as X, 0.56. Axial factor or axial load factor or thrust factor, that I am denoting as Y, which is 1.2. So I can convert this into equivalent load. How I will discuss, but first I am writing all the data. Dynamic load carrying capacity of the bearing is 40 kilonewton. Dynamic load carrying capacity is nothing but it is load carrying capacity for 1 MR rated life. This corresponds to this rated life is always 1 MR. But then what is the actual life of the bearing and actual rated life of the bearing? That also exam asking in MR. Means life corresponds to actual load. But we will convert this actual load into equivalent single equivalent load, which we denote as P. And formula to calculate this single equivalent load P is XVFR plus YFA. See, the factor which I am multiplying in FR is known as radial factor, it is given. The factor Y which I am multiplying in axial load is known as axial load factor, it is also given. But what about Y? In FR we multiply one more factor which is, what about V? In FR we multiply one more factor which is V, which is known as rotation factor. If it is given, good. If not given, always take value of V equal to 1. So here X is 0.56, V is 1, FR is 20 plus Y is 10, Y is 1.2, FA is 10. So how much equivalent load is coming? 0.56 into 20 plus 1.2 into 10. Check the calculation. Is it coming 23.2 kilonewton? Okay. Now bearing is ball bearing. So see, in terms of dynamic load carrying capacity, because in question dynamic load carrying capacity is given, what is load life relationship? In types of dynamic load carrying capacity you can always remember, but it is in terms of dynamic load carrying capacity. L is equal to C upon P to the power K. What is K? I will explain. Okay, where C is dynamic load carrying capacity, means load carrying capacity for 1 MR rotated life, and L is actual rated life, corresponds to actual load. Okay, but this L is actual rated life in MR. Exam asking in MR, but suppose exam asking in hour, but from here I will get in MR, then you can convert that in hour. That is different thing. But I know examiner is asking in MR, so I have no issue. So here L is rated life. First of all, again it is rated life for actual load, and what is C? C is dynamic load capacity. So this is load life relationship for in terms of dynamic load capacity. Now what is K? K is 3 for ball bearing and 10/3 for roller bearing. Right now it is ball bearing, so K will be equal to 3. So C is given, actual load is given, exam asking rated life in MR. So from this I can calculate. because L is equal to C upon P to the power K. C is 40 upon P. P is actual equivalent load 23.2 to the power 3. So how much actual rated life in MR is coming? 40 divided by 23.2, then it's cube. Is it coming? Very good. 5.125 MR, and it is rated life, na? So actual rated life is 5.125 MR. Very, very, very good. MR in MR, Jana's ki round up to 2 decimal place. So if you round up 5.12 up to 2 decimal place, mathematically it will be 5.12. Very good. Now next question. For rolling contact bearing. These are formula based question. Solve this. This is multiple choice question. Na? What this question is saying, a journal bearing has a shaft diameter 50 mm or journal diameter, length 50 mm. The shaft is rotating at 20 pi radian per second. It is given in radian per second. The viscosity of the lubricant is 25 centipoise. Capital P is for poise. So it is given in centipoise. The radial clearance is 0.025 mm. Radial load in the bearing is 10 kilonewton. So what is Soderberg number? This is very easy question because it is simple formula based question. What will be the answer for this question? See, it is a journal bearing in which the diameter of the shaft, I am writing here, small d is 50 mm. Length of the bearing is also 50 mm. Shaft is rotating at 20 pi radian per second. So here speed is given in radian per second. Generally speed in radian per second I denote as omega. It is 20 pi, don't forget pi, radian per second. Now viscosity of the lubricant, that is Z is given, it is 25 centipoise. Radial clearance CR is given, it is 0.025 mm. Then what is radial load on the, radial load in the bearing is also given, it is 10 kilonewton. So what is Soderberg number, that I denoting as S. Now for sliding contact bearing, journal bearing, the formula to calculate Soderberg number is ZNS by small p into R by CR whole square. Okay, now be careful with unit. Here Z is dynamic viscosity of the lubricant in Pascal second using SI unit. And what is P? P is bearing pressure in Pascal. If you are putting Z in Pascal second, calculate P in also in Pascal. Now what is NS? NS is speed of the shaft, but not 20 pi. It is radian per second. Here NS is speed, because we student do mistake in unit of speed. In RPS, RPS is round per second, not radian per second. So first of all, whatever speed is given, convert that in RPS. Now R by CR square, in R by CR, R is radius, CR is radial clearance. So see, this is separate unitless ratio, na? So I will calculate R by CR separately, but first I am finding Z small p NS, which is the part of this equation. So Z is dynamic viscosity, it is given, but convert that in Pascal second. So see, first of all, it is 25 centipoise. Now 1 cent is 10 to the power minus 2. So can I say it is 25 into 10 minus 2 poise? Now 1 poise is 10 to the power minus 1 Pascal second, because 1 Pascal second is 10 poise. You will study in this thing is in FM. So 1 poise is 10 to the power minus 1 Pascal second. So multiply again with 10 to the power minus 5, minus 1, sorry. So it will be 20 into the power minus 3 Pascal second. Okay. Now P is bearing pressure in Pascal. So calculate bearing pressure Pascal. Bearing pressure formula is W upon L into D. But here I will put all the value in SI unit because we have to calculate bearing pressure in Pascal. So W is radial load in the bearing in Newton. So 10 kilonewton Newton, it will be 10,000 Newton. Upon L, L is length of the bearing in meter. It is 50 mm. So in meter 0.05 meter divided by small d is diameter in meter. It is 50 mm. In meter it will be 0.05 meter. So how much bearing pressure is coming in Pascal? 10,000 divided by 0.05 divided by 0.05. Is it coming 4 into 10 to the 6 Pascal? Now what is NS? NS is speed in RPS. So right now, see, speed in radian percent is given omega. Now suppose speed in RPM is N, so you study, you know this formula, na? Omega will always be 2 pi N by 60, where N is speed in RPM. And can I say N by 60 is nothing but speed in RPS? Because capital N is speed in RPM, round per minute. Below side minute is coming. So to convert minute into meter, which is coming below side, we need to multiply 60 below side. So N by 60 is nothing but speed in RPS, which is NS. So can I say omega is 2 pi NS? So from this we can calculate NS, because omega is 20 pi radian per second. it is equal to 2 pi ns. So how much ns is coming? 10 rps. So we calculated Z NSP. Now R by CR whole square. For that separately I am calculating R by CR. It is separate unitless ratio, na? So here what you can do, either put both R and CR in mm because it is unitless, or put both in meter. So suppose I am putting here in mm, na, because it is unitless ratio. So CR in mm 0.025 mm. Now what is the small r? Small r is the radius of the shaft. It will be small d by 2. Small d is 50 mm. So 50 by 2 it is 25 mm. So I am putting both in mm. So because it is unitless ratio. So 25 mm small r, CR is 0.025 mm, or put both in meter. So how much it is coming? 1000. Now we can calculate Sommerfeld number. Z is 25 into 10 minus 3 Pascal second. NS 10 RPS. Bearing pressure 4 into 10 is 6. R by CR whole square. R by CR is 1000. It's a square. How much it is coming? Is it coming 0.0625? Clear? So for this question, the value of Sommerfeld number is coming 0.0625, matching with which option? Option B. Clear? Even if you do small mistake now, you will get incorrect answer. Suppose instead of 25 into 10 minus 3, suppose you are taking 25 into 10 minus 2, you will get A. If you are not putting speed in RPS, you are putting in radian percent, that might be possible you are getting some answer which is mentioned in C and D. So don't do mistake any. Okay. If you are not doing any mistake, then your correct answer should be B, which is 0.025. Very good. Yes. Now solve this question. See, this is multiple choice question. What this question is saying, a 120 mm diameter shaft is supported by a bearing of length 90 mm with a diametral clearance 0.12 mm. It is lubricated by oil having viscosity of 75 millipascal second, small m for milli. Shaft rotates at 720 rpm and carries a radial load, but value of that load is not given, but it's saying carries a radial load. Then what is power loss? Okay. Whether it is 138, it is approximate value 868, 276 or 1736. It is MCQ na, so only one option will be correct. So see. First I am writing given data. It is the shaft whose diameter is 120 mm. Length of the bearing is 90 mm. With a diametral clearance is given, it is 0.12 mm. You will calculate radial clearance, it is half of this. If you want, it will be, I think, 0.06 mm. You can check the calculation. Viscosity is 75 millipascal second. Z is given 75 millipascal second. If you convert this in pascal second, 1 milli is 10 to the minus 3. So it will be 75 into 10 minus 3 pascal second. Speed of the shaft is given in RPM, that is capital N. It is 720 RPM. It is carrying a radial load. Then we are asking what is power loss. Okay. Now see, to calculate power loss, first we need to find frictional torque loss, because power loss is nothing but omega into torque loss, where omega is speed in radian per second. But first find torque loss. Now in radial journal bearing, the formula to calculate torque loss is mu equivalent, where mu equivalent is equivalent coefficient of friction, into W into small r. Okay. Small r is radius of the shaft, W is radial load, mu equivalent is equivalent coefficient of friction. Okay. But here mu equivalent is not given. Whenever mu equivalent is not given, to calculate mu equivalent, we will always use Petrov equation. So here says mu equivalent is not given, so we will calculate mu equivalent by Petrov equation. What is Petrov equation to calculate mu equivalent? 2 pi square ZNS upon small p into R by CR. Okay. But here you might think one problem will come, because here pressure I cannot calculate, because W is also not given, because in question neither W is given nor pressure is given. So if pressure is not given and W is not given, because formula to calculate bearing pressure P is W upon L into small d, but W is also not given. So here P is unknown. So sir, 𝐂𝐚, you will not get actual value of 𝐂𝐚, exact value of 𝐂𝐚. But our objective is not to calculate 𝐂𝐚. Our objective is to calculate torque loss, because for power loss, first I want to calculate torque loss. So see, if pressure is not known, but can I say other parameter is known? First understand how we can solve this type of problem. 𝐂𝐚 will come in terms of pressure. Suppose by putting other value, other value are coming K. So 𝐂𝐚 will come like this, K by P, just for understanding. It will come in terms of pressure, and pressure is coming below. So no problem. Torque loss you can calculate exactly, because what is the formula to calculate W? Can I say W is nothing but pressure into L into small d? Because pressure is W by LD, so W will be P into LD into small r. So this is the expression of W. So what will happen now when you put the expression of 𝐂𝐚 like this? Okay, below set pressure is coming, here above set pressure is coming. So pressure will automatically get cancelled, and will get exact value of torque loss. So in this type of problem, if neither pressure nor W is given now, so calculate 𝐂𝐚 in terms of pressure and put here. Okay, so apart from pressure now, but for the to calculate 𝐂𝐚 in terms of pressure, we need to find other part. So Z is viscosity in Pascal second, calculate given. NS is speed of the shaft in RPS, round per second. So see, if speed in RPM is capital N, speed in RPS NS, it will be capital N by 60. Capital N is 720 divided by 60. How much it is coming? I think 12 RPS. Check the calculation. 720 by 60. Yes, 12 RPS. Okay. Small p in terms of P I am calculating. R by CR is separate unitless ratio, na? So separately I am calculating R by CR, small r by CR. Small r is radius of the shaft, CR is radial clearance. Either put both in mm, both in meter, because they are unitless ratio. So small r is radius, na? So diameter is 120 mm. In meter it will be 0.12 meter. So smaller radius will be half of this, that is 60 mm. In meter it will be 0.06 meter. But here it is usually, because it is unitless ratio, either put both in mm or put both in meter, because this is unitless ratio. Suppose I am putting both in mm, so small r in mm is 60 mm, then CR also in mm, it is 0.06. If you want, you can put both in meter also. So 60.0.06, it is coming 1000. So just put here 2 pi square into Z 75 into 10 minus 3 NS 12. P is not known. R by CR is unitless ratio, which is 1000. So how much it is coming? 2 pi square into Z. Is it coming 17765.288? Check the calculation. (17765.288) divided by pressure. Clear? Yes. So 𝐂𝐚 is 17765.288 upon pressure into P into. Now here I will put the value with SI unit, because while calculating torque loss I am using SI unit. So we'll get torque loss in Newton meter. So length of the bearing in meter. So length of bearing in mm is 90 mm. So in meter it will be 0.09 meter. So L is 0.09. Small d is diameter of shaft in meter, which is 0.12 meter. Small r is radius of the shaft in meter, which is 0.06 meter. Okay, and this P and P will get cancelled, so you'll get exact value of torque loss. How much it is coming? Into 0.12 into 0.06. Is it coming 11.512 Newton meter? Yes. And after calculating torque loss, we can calculate power loss. See. Now again, don't do mistake with unit. Power loss is always omega into torque loss, where omega is speed in radian per second. Don't put speed in RPS here. Speed is in radian per second. Now if speed in RPM is capital N, we know speed in radian per second will be 2 pi capital N by 60 into TF. So 2 pi capital N is 720 divided by 60 into torque loss is 11.512. So how much power loss is coming? 2 into pi into 720 divided by 60. Is it coming nearly 867.98 watt? Now see which option is near to this answer. Near to 867.98. Option B. So for this question, the correct answer is B for Bombay. Very good. Clear? So like this, we'll solve this type of problem. Now, coming back to next question, it is the question of design of gear. What this question is saying, it is required to design a pair of spur gear with 20-degree full depth involute teeth consisting of 28 teeth pinion meshing with 56 teeth gear. The pinion shaft is connected to a 18 kilowatt 1000 rpm electric motor. So this is the speed of pinion. Okay. Permissible bending stress is 140 megapascal. See, here only permissible bending stress is given. It means both gear are pinion and wheel are made of same material. Okay, and permissible stress of both gear is 150 megapascal. Okay. Now dynamic factor is 1.35. Module is 4 mm. Lewis form factor is 0.31. Then face width of the gear. Okay. Actually, it should be mentioned that is the Lewis form factor of which gear? Actually, it is for pinion. Lewis form factor of pinion is 0. It should be mentioned, but even it is not mentioned, now we'll consider if only Lewis form factor is given. That is given for required gear. Here here we require the Lewis form factor of pinion. How I will explain. So actually it is Lewis form factor of pinion, but it should be mentioned, but it is not mentioned. You can directly consider this as the Lewis form factor of pinion. Then he is asking what is the face width of the gear. It is the question of designer because permissible stress is given. See, first I am writing the given data. In this question, pressure angle is 20 degree. Number of teeth on pinion, that is TP, is 28 and number of teeth on wheel is 56. In larger gear, that is wheel. The pinion shaft is connected to 18 kilowatt power. See, power will be same whether it is pinion or wheel. 18 kilowatt, in watt it will be 18,000 watt, and this is the speed of pinion because speed of the shaft in which pinion is mounted gear. Means it will is also speed of pinion. It is 1000 rpm. It is given in rpm, so I am denoting as NP. Okay, now permissible bending stress is 140 megapascal. Okay. Dynamic factor is 1.35 kd. And module is form 4 mm. And Lewis form factor of pinion is given 0.31. Even if pinion is not given, it is Lewis form factor of pinion. Why? I will explain. Don't worry. Then exam asking face width. Since permissible stress is given, means it is the question of design. First of all, understand I am making a quick summary. See, in a gear, what is Lewis formula to calculate bending stress? It is PT is equal to PT is tangential force transmitted by gear, and this is always equal to M. M is module of gear. B is face width. Sigma B is maximum bending stress for the gear for which I am applying this formula into Y. Y is Lewis form factor of respective gear in which we are applying this formula. Now, some modification factor if they are present. Now, whenever modification factor is given, like here dynamic factor is given, just see whether it is less than 1 or greater than 1. If it is less than 1, we'll multiply that factor in RHS. If it is less than 1. If this is more than 1, we'll divide that factor in RHS. So, this is formula is Lewis formula. Now, here doesn't matter for which gear you are applying this formula. PT, M and B will always be same because PT, M and B are same for both pinion and wheel. But sigma B is maximum bending stress of that gear for which I am applying the formula. If I am applying the formula for pinion, it is for pinion. If I am applying for wheel, it is for wheel. Y is least form factor of that gear. But see, if it is the question of design, design means permissible stress is given, then we'll apply this formula always for weaker gear. If pinion is weaker, we'll apply for pinion. If wheel is weaker, we'll apply for wheel. Now, if the material of both gear are same, like in this question it is same because permissible stress are given. Permissible stress is same given, means permissible stress of both pinion and wheel is this. In that case, you can directly remember always pinion will be weaker. So, since pinion is weaker, we require the data for pinion. That's why I am saying if it is not mentioned, consider this as the Lewis form factor of pinion because that will be required. If permissible bending stress of both gear are different, how will come to know? In question suppose given permissible bending stress of pinion is 100, permissible bending stress of wheel is 200. So, if permissible bending stress of both gear are different, then to identify which gear is critical, we calculate a factor which is known as strength factor. Strength factor, I am just giving a quick review. Strength factor is nothing but it is the product of permissible bending stress. It is not actual, it is permissible bending stress into Lewis form factor. So, we'll calculate this factor for pinion also, calculate this factor for wheel also, and for whichever gear this factor is coming less, that will be critical. But if permissible stress are same, this factor will always come less for pinion. In that case, pinion will always be weaker. So, right now for this question, permissible stress are same, that's why pinion will be occur. But if they are given different, calculate this factor for whichever gear it will come less, that will be critical. Okay. Okay. Now whichever gear is critical will apply this Lewis formula for that critical gear, and in that gear will equate bending stress with permissible because we are doing designing. But for which gear will apply this formula? For critical or weaker gear. Okay. Now here come back to actual question. Here only one permissible stress is given. Okay, means permissible stress of both gear are same. So here pinion will be weaker. So here we'll apply this Lewis formula for pinion. It will be PT is equal to, it doesn't matter for which gear we are applying formula, PT, M and B will be same. Now other part will depend. Sigma B, it is now maximum bending stress of pinion into Y Lewis form factor of pinion. Now in factor only dynamic factor KD is given. And importantly, it is more than 1. If it is more than 1, just divide that in RHS, first of all. But since we are applying this formula for pinion, this Y will be Y of pinion. And since it is the question of design, we will equate this bending stress with permissible bending stress. Okay. Simply I am writing permissive because right now it is same for both gear. Okay. Okay. And why pinion is weaker? Because permissible stress of both gear are same. Now through this we can find the limiting value of phase width, that is B. It is given, KT is given, M is given. Now to calculate B, first I need to find the value of PT, which is tangential force. Don't say we have to calculate tangential force of pinion. It will come same for both pinion and wheel. Now to calculate tangential force, first I need to calculate torque of any gear, whether you are calculating for pinion or wheel, doesn't matter. So right now power is given and speed of pinion is given. So I am calculating torque of pinion. So power will be omega into torque, omega pinion into torque of pinion, that I am denoting as empty pinion. For torque here I am taking empty notation because T notation I am taking for number of teeth. So to avoid a confusion, for torque I am using empty, and this is the torque of pinion. Now power is 18,000 watt equal to omega is pinion 2 pi is into speed of pinion in RPM 1000 divided by 60 into empty pinion. So from this we'll get the value of empty pinion. How much it is coming? 18,000 into 60 divided by 2 divided by pi divided by 1000. Is it coming? 171.8873 Newton meter. In Newton mm it will be 171,887.3 Newton, because in further calculation for force I am taking Newton, for dimension I am taking mm. Now what is the formula to calculate torque of pinion? It is always PT, which is tangential force transmitted, into piece circle radius of pinion. So from this to calculate PT, now we have calculated empty pinion. Now I need to find piece circle radius of pinion. Now piece circle radius of pinion, it will be module into number of teeth on pinion divided by 2. Yes sir. Now module is 4 mm. Number of teeth on pinion is 28. So it is 4 into 28 divided by 2. How much it is coming? 4 into 28 divided by 2. It is coming 56 mm. Check the calculation. Just put here. I am putting torque in Newton mm. It is 171,887.3 equal to PT. Then put radius also in mm. Piece radius in mm is 56. So we'll get PT in Newton. How much it is become? 171,887.3 divided by 56. Is it coming? 3069.416 Newton. Check the calculation. Yes. Now just put PT here. 3069.416 equal to 4 mm. B I want to calculate. Sigma BP permissible bending stress, which is 140. YP loose form factor is 0.31. So 140 into 0.31 into 1 upon KD, which is 1.35. So from this we can calculate the limiting value of face width. How much it is coming? 3635 divided by 4. You can check the calculation. It is coming 23.87 mm. Now see which option is near to this. So your limiting value of face width is coming 23. See it is NAT question. So it is coming 23.87 mm. Exam asking round up to 2 decimal place. So round up to 2 decimal place. Correct answer for this question is 23.87. Very good Varek, very good Divya Narang, very good Rohan. Clear? So this is correct answer for this question. Now moving to next question. This is multiple choice question. It is the question of spring. What this question is saying? A closed coil helical spring is made of 10 mm diameter steel wire consisting 24 ton. Spring index is 12. Spring index we denote as C, which is nothing but capital D by small d. Capital D is mean coil diameter, small d is mean wire diameter. Tensile strength, it is tensile strength is 480, factor of safety 2.5. The effect of direct torsion shear stress, maximum load which spring can carry as per, if tensile strength is given, examiner should mention as per which theory. So as per Tresca's theory. Now this question is complete. But in spring, if tensile strength is given and theory is not mentioned, I will suggest use Tresca's theory, because generally we use this theory for spring design. But if it is not mentioned, like suppose in question shear strength is given, then there is no confusion. We'll calculate overall tau max, that should be less than equal to shear strength tau f. For design, we'll replace tau f by tau f upon fs. But if tensile strength is given, but actually stress in spring is the shear, so theory should be mentioned. So is this Tresca's theory. In Tresca's theory, again criteria of failure is overall tau max. So we'll calculate. But this overall tau max will consider the effect of direct and torsion shear. But nowhere it is mentioned we have to consider curvature effect also. So we'll consider only direct and torsion shear. See, actually in closed coil helical spring, whenever spring is subjected to axial load P, okay. So due to that load P, in the cross section of spring, actually two effects come. One is shear force P, and second one is torsion moment P into capital R. Capital R is mean coil radius. This we have discussed in the class, so I'm not going in detail. Okay. So if your objective is to calculate maximum shear stress, sometimes we calculate maximum shear stress by considering only torsional shear. Means we neglect the effect of direct shear, because as compared to torsion shear, direct shear is very less. So if we only consider torsion shear, the tau max will be maximum torsion shear stress. And for circular cross section of diameter D, diameter is suppose small d, and torsion moment is T, we know maximum torsion shear stress is 16T upon pi d cube. So here it will be 16P capital R, which is torsion moment is P into capital R. This you can keep in your mind, upon pi small d cube. But in this formula, we have considered only torsion, but we have neglected the direct shear effect. We have neglected the effect of curvature also. I am just writing all the formula to avoid any mistake in actual gate exam. Okay, yes. But if you consider the effect of direct shear also, then the formula to calculate tau max is you can remember in two way. In maximum torsion shear stress, which is 16P capital R upon pi small d cube, to consider the effect of direct shear, just add direct shear stress here. Direct shear stress will be force upon area. Force is P upon area will be pi by 4. 4 will go above side, small d square. Or another way is, first write 16P capital R pi d cube means maximum torsion shear stress. Definitely, if we will consider the effect of direct shear, actual shear will be more than this. So to consider the effect of direct shear, here we multiply factor, which is 1 upon 1 plus 1 upon 1 2c. This you can remember. Both formula are same. From this formula, if you take 16 PR upon pi d cube and do simplification, you will get this answer. Okay. So you can remember this 1 plus 1 upon 2c. Here we have considered torsion. Here we consider direct shear. But here we have neglected curvature effect. Okay. Now, sir, if you want to consider curvature effect also, then the formula to calculate tau max is Kw, which is wall correction factor, into 16P capital R upon pi d cube. Means first write maximum torsion shear. In this, if you want to consider direct shear only, multiply this. And if you want to consider direct shear also, curvature effect also, then multiply Kw. And if Kw is given, good. Otherwise, formula to calculate Kw is 4c minus 1 upon 4c minus 4 plus 0.615 upon c. Okay. But right now, which formula we'll use? We'll use this, because examiner consider direct shear and torsion shear. Nothing is related to curvature effect. Okay. See, if in actual question it is not mentioned that which we have to consider now, then always we'll use this formula. We'll consider direct shear, but we'll neglect curvature effect, because it is empirical relation. Actually, it is empirical. So this we will only use when examiner is saying to use. Otherwise, use this formula. Right now it is written, we have to consider direct shear, that's why I will use this formula. But we have to not consider curvature effect, because nothing it is written. So I am using this formula. Okay. Okay. Now, this is the expression of tau max. Now, tensile strength is given. So whatever formula we are using, we know that tau max, as per Tresca's theory, it should be less than equal to maximum shear stress under tensile test, because in question tensile strength is given. And suppose tensile strength I am denoting as, what notation I have taken here? Tensile strength I am denoting as, first I am writing the given data, it will be better. Wire diameter small d is 10 mm, number of turn n is 24. Tensile strength, suppose I am denoting as sigma f, it is 480 megapascal, or you can denote as SUT. Okay. Factor of safety is 2.5. We have to consider the factor of direct torsion shear. We have to calculate the maximum load which is spring inch carry. Suppose that I am denoting as P. Okay. So see, is question tensile strength is given. Na? So this overall tau max, it should be less than equal to maximum shear stress under tensile test. If tensile strength is sigma f, maximum shear stress under tensile test will be 0.5 sigma f. If sigma f is tensile strength. Now for design, we'll replace sigma f by sigma f upon fs. Then to find limiting value, we can use equal to sign. If directly shear strength is given, then directly we will equate tau max by shear strength upon fs. But since shear strength is not given, it is tensile strength. So maximum shear stress under tensile test will be 0.5 sigma f. Then replace sigma f by sigma f upon fs. Now tau max expression is, I am using this formula, 1 plus 1 upon 2c 16 p capital R upon pi small d cube equal to 0.5 sigma f upon fs. Now I am putting the spring index is given. Spring index left na, it is 12. Through this you can calculate capital R also, okay, because spring index is capital D by small d. So capital D upon small d is 10 equal to 12. So capital D will be 120 mm. Then capital R is half of capital D, that is 60 mm. So 1 plus 1 upon 2c, c is 12. 16p capital R is, I think, 60 mm upon pi small d cube, small d is 10, so 10 cube equal to 0.5. Sigma f tensile strength is 480, factor of safety is 2.5. So how much the limiting value of P is coming? Is it coming 301.593 Newton? So nearly it is coming 301.59. See, now see which option is near to this, option C. So for this question the correct answer is C. Okay. So I completed this now. I discussed 20 question, 20 most important question, and I had tried to take those questions in which you can revise entire subject. Okay. So if you see my notes of Maharevision, if you will follow this, and in the evening I am going to take one more session which is Mahabhyas in 𝐂𝐸 YouTube Hindi channel, 𝐂𝐸 Mechanical MEXE channel. So in that channel also I will discuss variety of questions. So even in this last time, if you are only focusing on your notes, Maharevision notes, and going with solving these questions which I have completed right now and which I am going to complete in the evening also. I think timing is 7 p.m. It is more than sufficient for you. Okay. So all the best. Okay. And we'll meet in the evening, na? Because in evening I am going to take Mahabhyas session. So I will discuss variety of question, and if you are completing Maharevision Super 20 Mahabhyas, that is more than sufficient for revision. Okay. Finding. Around 25, Rohan. I think it's 27. Ending.